Chapter 1. Introduction and preparation for the journey. Close your eyes now, and let yourself sink into the gentle embrace of this moment. Feel your body settling into stillness, like a leaf coming to rest on the surface of a tranquil pond. Breathe deeply, slowly, allowing each exhale to carry away the weight of the day, the concerns that have followed you here, the thoughts that flutter like moths around the lamp of your consciousness. Now, in this sacred space of quietude, I invite you to lift your inner gaze upward, beyond the ceiling above you, beyond the roof that shelters you, beyond the atmosphere that cradles our world. Imagine yourself rising gently, effortlessly, until you find yourself suspended in the vast cathedral of night, where countless stars hang like ancient chandeliers, their light having traveled impossible distances just to reach this moment, just to meet your wondering eyes. The night sky stretches before you now, infinite and welcoming, a doorway carved from velvet darkness and adorned with diamonds of light. Each star you see is a sun, burning with the same fierce joy as our own, yet so distant that their warmth reaches you not as heat, but as whispered stories of cosmic time. Some of these lights began their journey to you when the pyramids were young, when mammoths walked the earth, when your ancestors first looked up in wonder and felt the same stirring in their hearts that you feel now. Feel the profound silence that surrounds you. It is not the empty silence of absence, but the full silence of presence, the silence that holds all possibilities, all dreams, all the unspoken poetry of existence. In this silence, stars are born and die, planets spin their ancient dance, and comets write their names across the darkness in trails of ice and light. Tonight, you are not merely an observer of the cosmos. You are a participant in its grand symphony, a note in its endless song. Your heartbeat echoes the rhythmic pulsing of neutron stars. Your breath mirrors the stellar winds that blow through space. Your thoughts ripple outward like gravitational waves, touching the farthest corners of reality. I am here as your guide on this journey, a voice to accompany you as we venture together into the deep places, the quiet places, the places where wonder lives. We will travel not in rockets or spaceships, but on the wings of imagination, carried by curiosity and cushioned by peace. We will visit the wanderers and the guardians, the dancers and the dreamers of space, each with their own story to tell, their own gift to offer. The universe awaits us with the patience of eons. It has been preparing for this moment since the first light broke the cosmic dawn, since the first atoms joined hands to create matter, since the first planets began their slow waltz around their parent stars. And now, in this perfect stillness, we are ready to begin. Let yourself become as light as starshine, as free as the solar wind, as open as the space between galaxies. We are about to embark on a journey that will take us from the intimate sphere of our own solar system to the vast spiral arms of our galaxy, from the fleeting beauty of shooting stars to the patient persistence of wandering comets. As we prepare to depart, feel how the darkness around you transforms from something to be feared into something to be embraced. This is not the darkness of confusion or loss, but the darkness of infinite possibility, the darkness from which all light emerges. You are safe in this darkness, held by the same forces that guide planets in their orbits and keep the stars burning bright. Your breathing has become deeper now, more rhythmic, matching the ancient rhythms of the cosmos itself. With each breath, you are drawing in stardust, for that is what you are made of, what we are all made of. The calcium in your bones was forged in the hearts of dying stars. The iron in your blood was born in stellar furnaces. The oxygen you breathe was gifted to the universe by stars that lived and loved and died billions of years before the Earth was even a dream in the cosmic mind. We are about to witness the gentle violence of meteors, painting brief masterpieces across the sky, to follow the patient pilgrimage of comets as they swing through their millennial orbits, to drift among the ancient asteroids that have kept their vigil in space since the solar system's youth. We will walk the rust-colored plains of Mars and feel the whisper of alien winds, and we will lose ourselves in the spiral embrace of our galaxy, that great wheel of light that carries us all on its turning. But for now, in this moment of preparation, simply be. Be present to the vastness that surrounds you. Be open to the mystery that calls you. Be willing to let wonder wash over you like warm rain on a summer evening. The cosmos is not a cold, hostile place. It is your home, your birthplace, your destiny. You belong here among the stars, as surely as fish belong in the ocean or birds belong in the sky. The journey we are about to take together is not measured in miles or years, but in moments of recognition, in instants of understanding, in the gradual awakening to the truth that you are not separate from the universe. You are the universe experiencing itself through your eyes, dreaming itself through your dreams, loving itself through your capacity for wonder. So rest now in this threshold moment, this pause before the dance begins. Feel your connection to everything that is, to the nearest star and the farthest galaxy, to the smallest grain of cosmic dust and the largest cluster of celestial bodies. You are woven into the fabric of space and time, a unique and irreplaceable thread in the tapestry of existence. The stars are calling, and we are ready to answer. The cosmic ballet is about to begin, and you have the best seat in the house, the seat of consciousness itself, the viewing platform of awareness, the observatory of the soul. From here, we can see clearly, feel deeply, understand intuitively the profound connections that bind all things together in one magnificent, ever-unfolding story. Take one more deep breath, and as you do, imagine that you are breathing in the essence of starlight itself, the fundamental energy that powers all of creation. And as you exhale, let yourself settle even more deeply into the peace that passes understanding, the tranquility that comes from knowing your place in the grand design, your role in the cosmic conversation. We are ready now. The universe is waiting. Our journey into wonder begins. Chapter 2. The magic of shooting stars. In the deep quiet of our cosmic sanctuary, something magical is about to happen. Do you feel it? A subtle stirring in the darkness, a gentle anticipation that whispers through the stellar winds. We are about to witness one of nature's most enchanting performances, the dance of shooting stars across the velvet canvas of night. But first, let us understand these celestial messengers, these brief visitors that streak across our awareness like thoughts across the mind. What you call a shooting star is not truly a star at all, but something far more intimate, far more connected to our own story. These are meteors, tiny fragments of cosmic debris, no larger than grains of sand or small pebbles, that have been wandering through space for millions of years, perhaps billions, carrying within them the memory of ancient collisions, of asteroids that shattered in the long ago, of comets that shed their skin of ice and dust as they danced too close to the sun. Picture these small wanderers in your mind's eye. They drift through the cosmic ocean in perfect silence, following invisible currents of gravity, riding the subtle waves of solar radiation. For eons, they have known only the cold emptiness of space, the distant whisper of starlight, the patient waiting that defines so much of cosmic existence. They are the universe's nomads, carrying no homeland in their hearts except the vast expanse itself. And then, in a moment that changes everything, their ancient journey brings them into the sphere of Earth's influence. Our planet's gravity reaches out like a gentle hand, drawing these cosmic wanderers into its embrace. As they enter our atmosphere, something miraculous occurs. The friction of their passage through the thickening air begins to heat them, to wake them from their eons-long slumber. Watch now with your inner eye as one of these meteors begins its final, glorious transformation. At 60 miles above the Earth's surface, it starts to glow, its surface heating to thousands of degrees in mere seconds. The very air around it begins to fluoresce, to sing with light, creating a trail of luminous plasma that stretches behind the meteor like a river of liquid starlight. For just a moment, perhaps 2 or 3 seconds, at most, this tiny fragment of cosmic dust becomes more brilliant than any star in the sky. It writes its signature across the darkness in letters of fire, a brief poem of light that speaks of journeys measured in geological ages, of the interconnectedness of all matter, of the beautiful impermanence that defines our existence. Most meteors burn up completely in this moment of glory, their substance joining with the atmosphere, becoming part of the air we breathe. They sacrifice themselves in a burst of beauty, their long journey through space culminating in this single, perfect moment of illumination. In a sense, they choose light over matter, presence over persistence, brief magnificence over long obscurity. Some nights, when the Earth passes through the debris trail of an ancient comet, the sky comes alive with dozens, even hundreds of these celestial performers. These are the great meteor showers that have inspired wonder and storytelling for as long as humans have lifted their eyes to the stars. Let us journey together now to witness the Perseids, that annual celebration that occurs each August when our planet glides through the scattered remains of comets' swift tuttle. Feel yourself floating high above the Earth in the pre-dawn hours, when the sky is darkest and the stars shine with crystalline clarity. The constellation Perseus rises in the northeast, and from this celestial hero's domain, the meteors appear to radiate outward like spokes from the hub of a cosmic wheel. One streaks across the sky near the bright star Capella, a quick silver line that appears and vanishes in the time it takes your heart to beat. Another follows, then another, each one unique in its trajectory, its brightness, its color. Some burn white-hot, others glow with the soft gold of candlelight, and occasionally one will flare green or blue, its color telling the story of its composition: magnesium burning bright, iron painting trails of orange, sodium casting its yellow signature across the night. The Perseids are known for their reliability, their gentleness. They arrive each year like old friends keeping a long-standing appointment, filling the summer sky with their quiet fireworks. Indigenous peoples called them the tears of the gods, while others saw them as arrows shot by celestial hunters, or as the sparks that fly when the universe sharpens its tools on the whetstone of night. But if the Perseids are the gentle rain of summer meteors, the Leonids are the torrential downpour of late autumn. Every 33 years, when their parent comet, Tempel-Tuttle, returns to the inner solar system, the Leonids can produce storms of incredible intensity. Imagine, if you can, a night when the sky fills with thousands of meteors per hour, when the darkness comes alive with so much light that observers feel as though they are riding through space on the Earth itself, watching the cosmic debris part before them like the bow wave of a ship cutting through phosphorescent seas. There have been Leonid storms so intense that people thought the world was ending, so beautiful that they inspired religious experiences, so overwhelming that witnesses reported feeling dizzy, as though they could sense the Earth's motion through space. In November 1833, one such storm filled the American sky with an estimated 240,000 meteors per hour, causing some to believe that all the stars were literally falling from heaven. These great meteor showers remind us of our planet's journey through space, of the fact that we are not static observers but active participants in the cosmic dance. The Earth sweeps through space at 67,000 miles per hour, carrying us all on an adventure more magnificent than any earthly voyage. As our world encounters these streams of cosmic debris, we are reminded that space is not empty but filled with the remnants of ancient events, the scattered memories of the solar system's formation, the fossilized trails of comets that have been making their pilgrimages around the sun for millions of years. Each meteor tells a story that connects us to the deepest history of our cosmic neighborhood. Some are fragments of asteroids, chunks of rock and metal that have remained largely unchanged since the solar system's birth 4.6 billion years ago. These meteoric messengers carry within their crystalline structure a record of conditions that existed when the planets were still forming, when our region of space was a chaotic disk of gas and dust surrounding a young, variable star that would eventually become our stable, life-giving sun. Others are pieces of comets, carrying within their substance the frozen gases and organic compounds that may have seeded the early Earth with the raw materials for life itself. When these meteoric ambassadors burn up in our atmosphere, they are returning home in a sense, rejoining the Earth after eons of wandering in the cold depths of space. Their atoms become part of our planet's atmospheric chemistry, eventually settling into the soil, joining the water cycle, becoming part of plants and animals, and eventually, perhaps, part of other human beings. This cosmic recycling process connects us intimately to the larger universe. The carbon in your DNA, the calcium in your bones, the iron in your blood, all of these elements have been on incredible journeys through space and time. Some arrived on Earth during the early bombardment period, when our planet was still forming. Others may have been delivered more recently by meteors like the ones we are witnessing, cosmic delivery systems that continue to add their substance to our planet's ever-evolving chemistry. Throughout human history, meteors have been seen as omens, as messages from the gods, as bridges between the earthly and the divine. Their sudden appearance and brief duration made them perfect symbols for the ephemeral nature of existence, the way that all beauty, all life, all meaningful moments seem to shine brightest just before they fade. Ancient Chinese astronomers called them guest stars and kept meticulous records of their appearances, noting their colors, durations, and the constellations through which they passed. Greek philosophers debated their nature with characteristic intellectual curiosity. Were they atmospheric phenomena or truly celestial events? Aristotle believed they were exhalations from the Earth that caught fire in the upper atmosphere, while others proposed that they were pieces of the celestial sphere itself, fragments of the crystalline shells that they believed carried the planets in their orbits. These early attempts to understand meteors reflect humanity's eternal quest to comprehend our place in the cosmos, to find rational explanations for phenomena that inspire both wonder and mystery. Islamic scholars in the medieval period wrote extensively about meteors, seeing in their fleeting beauty a reminder of the transience of earthly life and the eternal nature of the divine. They developed sophisticated observational techniques and mathematical models to predict when meteor showers would occur, contributing to the gradual accumulation of knowledge that would eventually lead to our modern understanding of these phenomena. But perhaps the most universal human response to meteors has been the practice of making wishes upon them. This tradition, found in cultures around the world with remarkable consistency, speaks to something deep in the human psyche, the intuitive sense that these brief visitors from the cosmos carry with them some special power, some ability to connect our earthly desires with the vast forces that govern the universe. There is something profoundly moving about this practice when you consider it from a cosmic perspective. In the second or two that a meteor blazes across the sky, people have just enough time to form a wish, to focus their hopes and dreams, to send their thoughts upward with the dying light of the celestial visitor. It is as though the universe, in its infinite wisdom, has provided these brief moments of beauty specifically for this purpose, to give us a chance to articulate our deepest longings, to cast our hopes upon the cosmic winds, to participate in a ritual that connects us to both the stars above and the earth below. The practice of wishing on meteors represents a beautiful intersection of science and spirituality, of rational understanding and intuitive wisdom. We now know that meteors are natural phenomena governed by the laws of physics and orbital mechanics. Yet this knowledge does nothing to diminish their capacity to inspire wonder, to evoke feelings of connection to something larger than ourselves, to serve as catalysts for the expression of our deepest hopes and dreams. What is it about meteors that speaks so directly to the human heart? Perhaps it is their embodiment of the paradox of existence, itself the way that all beauty, all life, all love burns brightest just before it fades. They remind us that significance is not measured in duration, but in intensity, that a moment of true luminosity is worth more than years of dim persistence. In their brief perfection, they teach us about the preciousness of transient experiences, the importance of being fully present to beauty when it appears, the wisdom of appreciating what we have while we have it. Or perhaps meteors move us because they represent the universe's gift-giving nature in its purest form. Here are these cosmic wanderers, carrying nothing but their own substance, asking nothing from us, expecting no reward for their long journey through space. Yet in their final moments, they give us the gift of wonder, the gift of beauty, the gift of perspective on our place in the cosmic order. They remind us that the universe is fundamentally generous, constantly offering us experiences of awe and inspiration, if we are willing to look up and receive them. Meteors also embody the principle of transformation that governs all cosmic processes. They show us that endings can be beginnings, that destruction can be creation, that the same event can represent both death and birth, depending on your perspective. When a meteor burns up in our atmosphere, it dies as a cosmic wanderer but is born as earthly matter. Its atoms join the great recycling system that connects all matter on our planet, becoming part of the ongoing story of terrestrial evolution. This transformative aspect of meteors provides a powerful metaphor for understanding our own life experiences. Just as meteors must enter our atmosphere and undergo the friction of resistance in order to create their beautiful displays, we too must sometimes pass through periods of difficulty and challenge in order to discover our own capacity for brilliance. The heat and pressure that destroy the meteor's original form are the same forces that create its moment of glory, its opportunity to contribute something beautiful to the cosmic conversation. As we float here in our cosmic observatory, watching meteor after meteor paint its brief signature across the darkness, let yourself feel the deeper rhythms at work. Each meteor is both an ending and a beginning, the end of a long journey through space, the beginning of its return to planetary matter. Each streak of light represents the universe's way of recycling itself, of ensuring that nothing is ever truly lost, that every atom that was born in the heart of a star will eventually find its way into new forms, new stories, new possibilities for beauty and consciousness. Feel how these meteors connect you to the largest scales of space and time. That grain of cosmic dust burning up 60 miles above the Earth's surface may have originated in the asteroid belt between Mars and Jupiter millions of years ago, or it may be a fragment of a comet that last visited the inner solar system when your great-grandparents were children. Its atoms were forged in stellar furnaces billions of years ago, scattered into space by supernova, collected into planetesimals during the early formation of the solar system, and have been patiently waiting for this moment, this perfect intersection of trajectory and time that brings it into contact with our world. And in burning up in our atmosphere, this meteor becomes part of Earth's story once again. Its atoms will settle into the soil, join the water cycle, become part of plants and animals, and eventually, perhaps, part of other human beings. The cosmic wanderer completes its circle, returning to the planetary family after its long exile in the cold depths of space. In this return, we see reflected the larger pattern of cosmic evolution, the way that matter flows from stars to space to planets to life and back again, creating an endless cycle of transformation and renewal. This is the deeper magic of meteors, not just their beauty, not just their rarity, but their embodiment of the fundamental truth that everything in the universe is connected, that matter and energy are constantly flowing from one form to another, that we are all part of one vast, interconnected system of being. Each meteor is a reminder that you, too, are part of this cosmic recycling system, that the atoms in your body have their own deep history, their own journey through space and time, their own story of transformation and renewal. Consider the incredible journey that brought the iron in your blood to its current location in your circulatory system. This iron was forged in the core of a massive star that lived and died before our solar system existed. When that star exhausted its nuclear fuel, it collapsed and then exploded in a supernova that briefly outshone an entire galaxy, scattering iron-enriched material across hundreds of light-years of space. This iron drifted through the cosmic medium for millions of years, eventually becoming incorporated into the disk of gas and dust from which our solar system formed. Some of this iron became part of the Earth during its formation, while some may have been delivered later by meteorites and comets. Eventually, through the processes of geology and biology, this stellar iron found its way into your body, where it now plays an essential role in carrying oxygen through your bloodstream, enabling the cellular respiration that powers your consciousness and keeps you alive. Every breath you take depends on iron that was forged in the heart of a dying star billions of years ago. This recognition of your cosmic heritage transforms the simple act of watching meteors from passive observation to active participation in cosmic processes. You are not just watching cosmic material burn up in the atmosphere, you are witnessing the same type of transformation that brought you into existence, the same stellar alchemy that created the elements that make up your body, the same cosmic recycling that connects you to every star in the sky. As another meteor traces its brief arc across the sky, carrying with it the light of distant suns and the memory of cosmic events that occurred before the Earth was born, let yourself sink deeper into the peaceful awareness of your own place in this grand design. You are not an outside observer of the universe, you are the universe observing itself, learning about itself, falling in love with itself through your capacity for wonder and appreciation. The meteors continue their ancient dance, each one a small miracle, each one a gift freely given by the cosmos to anyone willing to look up and receive it. In their fleeting beauty, they carry a message of hope that even the smallest things can shine with incredible brightness, that even the briefest moments can contain infinite meaning, that the universe is fundamentally generous, constantly offering us beauty, wonder, and reasons for gratitude. Some meteors leave persistent glowing trails that can last for several minutes after the meteor itself has vanished. These trains are created when the meteor's passage ionizes the atmospheric gases, creating a tube of electrically charged particles that continue to glow even after the meteor has burned up completely. These persistent trains remind us that some influences continue long after their immediate cause has disappeared, that beauty and inspiration can outlast their original sources, that the effects of transformative moments can ripple through our lives for years or even decades after the experience itself has ended. The study of meteor trains has provided scientists with valuable information about the composition and dynamics of the upper atmosphere, those rarefied regions where Earth's atmosphere gradually transitions into the vacuum of space. By observing how meteor trains evolve and dissipate, researchers can learn about atmospheric winds, chemical composition, and the complex interactions between our planet and the space environment that surrounds it. But beyond their scientific value, meteor trains serve as beautiful metaphors for the lasting impact of brief but powerful experiences. Just as a meteor's passage can leave a glowing trail that persists in the atmosphere, moments of wonder, inspiration, or profound realization can leave lasting impressions on consciousness, continuing to illuminate our understanding long after the original experience has ended. The meteor shower you are witnessing now may last only a few hours, but its memory may inspire you for years to come, serving as a reminder of your connection to the cosmos and your capacity for awe and appreciation. Rest now in this understanding, in this connection to the cosmic gift-giving that surrounds us always. Let the peace of the meteor's message settle into your bones, the knowledge that you are held by the same forces that guide these cosmic wanderers, that you are part of the same grand story that began with the Big Bang and continues with each breath you take, each thought you think, each moment of wonder you experience. The meteors fade back into the darkness from which they came, but their gift remains the gift of perspective, of connection, of awe at the intricate beauty of existence itself. They have reminded us that we live in a universe where even the smallest fragments of cosmic dust can create moments of transcendent beauty, where the most ordinary processes can give rise to extraordinary experiences, where patience and presence are rewarded with glimpses of the divine play that underlies all of existence. Carry this gift with you as we prepare for the next stage of our journey, as we turn our attention to those larger wanderers, those ancient pilgrims of the solar system, whose journeys make the paths of meteors seem like brief afternoon strolls. We are about to encounter the comets, those magnificent time capsules from the solar system's birth, that carry ice and dust and organic compounds on orbital pilgrimages that can last for thousands or even millions of years, teaching us about patience, persistence, and the courage required to shine our light in the darkness regardless of how long the journey might take. Chapter 3. Comets, travelers of the solar system. In the profound silence that follows the meteor's gentle fireworks, we turn our attention now to their larger cousins, the grand wanderers of the solar system, whose journeys make the paths of meteors seem like brief afternoon strolls. These are the comets' ancient repositories of ice and dust and rock that have been making their patient pilgrimages around the sun since the solar system was young, carrying within their frozen hearts the memory of creation itself. Close your eyes and let your imagination carry you far from the warm embrace of Earth's orbit, far beyond Mars with its rusty dreams, past the asteroid belt where countless rocks spin in their eternal dance, beyond Jupiter with its swirling storms and retinue of moons, out to the cold, dark regions where the sun's warmth becomes a distant whisper and ice reigns supreme. Here, in this twilight realm at the edge of our solar system, billions of comets wait in a vast spherical cloud that surrounds our sun like an enormous snow globe. This is the Oort cloud, named after the Dutch astronomer who first imagined its existence, a reservoir of icy wanderers that extends halfway to the nearest star, each comet following an orbit so vast that a single journey around the sun takes thousands or even millions of years. Picture one of these patient travelers now, a dark nucleus of ice and rock, and frozen gases no larger than a mountain, tumbling slowly in the cosmic cold. For millennia upon millennia, it has known only darkness and the distant stars, its surface temperature hundreds of degrees below zero, its existence as still and quiet as death itself. This comet is older than any mountain on Earth, older than any ocean, older than life itself. It is a time capsule from the birth of the solar system, preserving within its frozen structure the same materials from which the planets formed 4.6 billion years ago. But now something changes. Perhaps it is the gravitational nudge of a passing star, or the subtle influence of a neighboring comet, but gradually, almost imperceptibly, this ancient wanderer begins to fall inward, drawn by the sun's distant gravity toward the bright center of our solar system. Its journey will take centuries or millennia, a slow spiral inward through the vast emptiness of space. As it falls sunward, crossing the orbits of the outer planets, The comet remains dark and silent, indistinguishable from an asteroid except for its eccentric path. But then, as it passes inside the orbit of Jupiter, something magical begins to happen. The sun's warmth, still faint but growing stronger, begins to wake the comet from its eons-long sleep. The ice within the comet's nucleus, water ice, but also frozen carbon dioxide, methane, ammonia, and dozens of other compounds, begins to sublimate, transforming directly from solid to gas without ever becoming liquid. This process creates a thin atmosphere around the comet's nucleus, a glowing cloud of gas and dust called a coma that can grow larger than the planet Jupiter, yet is so tenuous that it is more rarefied than any vacuum we can create on Earth. Watch now with your inner eye as our comet continues its approach to the sun. The solar wind, that stream of charged particles flowing outward from our star, begins to interact with the comet's coma, pushing the gas and dust away from the nucleus to form the comet's most spectacular feature, its tail. Not one tail, but a gas tail that glows with its own light as the solar wind energizes its molecules, and a dust tail that shines by reflected sunlight, creating a ghostly banner that can stretch for millions of miles across space. Here is one of the universe's most beautiful paradoxes. The closer a comet gets to the source of its illumination, the more of itself it gives away. Unlike the planets, which shine by reflected light while remaining essentially unchanged, a comet transforms itself in the act of becoming visible. Each close approach to the sun costs it some of its substance, some of its future. It trades permanence for beauty, longevity for a brief moment of spectacular visibility. The most famous of all comets is Halley's Comet, that faithful celestial timekeeper that returns every 76 years to grace our skies with its presence. This comet has been witnessed and recorded by human observers for over 2,000 years, appearing like clockwork in historical records from ancient China, Babylon, and medieval Europe. It has blazed across the sky during some of humanity's most pivotal moments, hovering over the Battle of Hastings in 1066, inspiring awe and terror in equal measure, interpreted by some as an omen of doom and by others as a herald of change. Imagine Halley's Comet on its long, elliptical journey. When it is farthest from the Sun, beyond the orbit of Neptune, it is cold and dark, moving at a mere 1,000 miles per hour through the frozen outer reaches of the solar system. But as it falls inward, accelerated by the Sun's gravity, it gains tremendous speed. By the time it rounds the Sun and begins its outward journey again, it is traveling at over 100,000 miles per hour, racing back toward the outer darkness with its tail streaming behind it like a victory banner. Each return of Halley's Comet connects the generations, linking us to our ancestors who looked up at the same celestial visitor with the same sense of wonder and mystery we feel today. The comet that graced the skies during your lifetime is the same comet that amazed the builders of Stonehenge, the same comet that the Roman historian Josephus described as a sword hanging over Jerusalem, the same comet that Mark Twain was born under and claimed he would die under and did, when it returned in 1910. But Halley is just one of many comets that have captured human imagination throughout history. There was the Great Comet of 1680, so bright that it could be seen in broad daylight, its tail stretching across a quarter of the sky. There was Comet Hale-Bopp, which graced our skies for months in the 1990, visible to the naked eye for longer than any comet in recorded history. A celestial visitor that reminded an entire generation that the universe is full of wonders beyond our daily experience. Each comet tells its own story, carries its own personality. Some are swift visitors, racing through the inner solar system on orbits that take only a few years to complete. Others are once-in-a-lifetime spectacles, appearing from the depths of space on orbits so vast that they will not return for tens of thousands of years, if ever. Some comets are predictable and well-behaved, following the same path orbit after orbit. Others are cosmic wildcards, prone to sudden brightening or unexpected fragmentation, reminding us that the universe always retains the capacity to surprise us. In ancient times, comets were almost universally viewed with fear and superstition. They were seen as harbingers of disaster, as warnings from the gods, as cosmic swords drawn against earthly kingdoms. The very word disaster comes from the Latin dis astrum, meaning against the stars, reflecting humanity's ancient belief that celestial phenomena could influence earthly events. Comets, with their sudden appearances and ghostly tails, seem to embody the universe's potential for chaos and change. But gradually, as human understanding of the cosmos deepened, comets transformed from objects of fear into sources of wonder and scientific fascination. In 1705, the English astronomer Edmund Halley used Newton's laws of gravity to predict the return of the comet that now bears his name, proving for the first time that these celestial visitors were not random portents but natural phenomena following predictable laws. This was a revolutionary moment in human thought, the realization that even the most mysterious celestial events could be understood, predicted, and appreciated for their true nature. Modern science has revealed comets to be far more than mere cosmic curiosities. They are libraries of the early solar system, carrying within their frozen nuclei samples of the original materials from which the sun and planets formed. When space missions like the European Space Agency's Rosetta probe landed instruments on Comet 67P/Churyumov-Gerasimenko, they found complex organic molecules, the building blocks of life itself. This discovery supports the hypothesis that comets may have played a crucial role in seeding the early Earth with the chemicals necessary for life to emerge. Think of this profound possibility. The water in your body, the carbon that forms your DNA, the amino acids that build your proteins, these may have arrived on Earth billions of years ago in the hearts of comets, ancient gift-bearers delivering the ingredients for life from the outer reaches of the solar system to our young planet. If this is true, then every comet that blazes across our skies is a reminder of our cosmic heritage, a distant cousin returning home to visit the children of the materials it helped deliver long ago. As we contemplate these wandering mountains of ice and rock, feel how their patient journeys mirror the larger rhythms of existence itself. Like comets, we all follow our own elliptical paths through life, sometimes racing through periods of intense activity and visibility, sometimes coasting quietly through times of reflection and preparation. Like comets, we all carry within us materials gathered from distant times and places, memories, experiences, wisdom accumulated over the years of our own orbital journey. And like comets, we all have our moments of transformation, times when the warming influence of love or challenge or inspiration causes us to release our own tales of creativity and beauty, to share our inner light with the world around us. These moments may come at great cost, just as comets lose some of their substance with each close approach to the sun, but they are also our moments of greatest visibility, our opportunities to contribute something beautiful and meaningful to the cosmic conversation. The comet's tail, streaming millions of miles behind the nucleus, serves as a perfect metaphor for how influence and beauty can extend far beyond their sources. Just as the comet affects space far from its physical body, creating a glowing presence that dwarfs planets, we too extend our influence beyond our physical forms through our words, our actions, our love, and our creativity. The beauty we create, the kindness we show, the wisdom we share, these form invisible tales that stream behind us through space and time, touching lives and situations far removed from our immediate presence. There is something profoundly moving about the comet's journey from the cold outer reaches of the solar system toward the warm embrace of the sun. It is a pilgrimage of transformation, a journey from invisibility to glory, from frozen potential to blazing actuality. In this journey, we see reflected the spiritual path of every conscious being, the long, slow movement from darkness toward light, from isolation toward connection, from dormancy toward awakening. The comet teaches us about patience and persistence. Its journey may take thousands of years, but it never wavers from its path, never doubts its destination, never grows weary of the long darkness that precedes its moment in the sun. There is a lesson here for all of us who sometimes grow impatient with our own journeys, who wonder if our efforts will ever be rewarded, who question whether we are moving in the right direction. The comet reminds us that some of the most beautiful transformations require long preparation, that the most spectacular displays of light often follow the longest periods of darkness. As you rest here in the quiet contemplation of these cosmic pilgrims, let yourself feel connected to their ancient journey. You too are a wanderer in space and time, carrying within your being materials that are billions of years old, following your own elliptical path through the experiences that shape and transform you. You too have periods of approach and retreat, times when you shine brightly for all to see and times when you travel quietly through the background darkness of preparation and reflection. The comets continue their patient dance around the sun, these ancient libraries of ice and dust and cosmic memory. Some will return in our lifetimes, giving us another chance to witness their beauty and contemplate their meaning. Others are making their final approach, destined to either crash into the sun or break apart under its gravitational stress, their long journey ending in a spectacular finale that seeds the solar system with their substance, contributing their ancient materials to the ongoing story of cosmic evolution. In their patient journeys, their spectacular transformations, and their generous gift-giving, comets embody some of the universe's most profound teachings about beauty, impermanence, and the courage required to shine our light in the darkness. They remind us that true beauty often requires sacrifice, that the most meaningful lives are those lived in service to something greater than ourselves, and that even in a universe that can seem cold and empty, there are always wanderers making their way toward the light. Rest now in this awareness, in this connection to the cosmic wanderers, whose tales of light and ice have inspired wonder and poetry for as long as humans have looked up at the stars. Let their patience inform your patience, their persistence inspire your persistence, their willingness to transform themselves for the sake of beauty encourage your own willingness to grow and change and shine. The comets fade back into the darkness from which they came, but their gift remains the gift of perspective on the long view of existence, the gift of understanding that some journeys are measured not in miles but in meaning, not in speed but in significance. Carry this gift with you as we prepare to visit another family of cosmic wanderers, the asteroids that dance in the space between Mars and Jupiter, keeping their own ancient vigil in the depths of space. Chapter 4: Asteroids and Wandering Bodies. From the spectacular displays of comets with their flowing tails of light, we drift now into a quieter realm of the solar system, a place where patience is measured not in centuries but in eons, where the dance of gravity plays out on the grandest scale, where countless small worlds spin in stately procession around the sun. This is the asteroid belt, that vast ring of rocky debris that orbits between Mars and Jupiter, home to hundreds of thousands of asteroids, ranging in size from grains of sand to minor planets hundreds of miles across. Let your consciousness expand now to encompass this enormous region of space, not the narrow band that illustrations often suggest, but a three-dimensional torus of immense proportions, wider than the distance from Earth to the Sun, and extending tens of millions of miles above and below the plane of the solar system. If you were to pilot a spacecraft through the asteroid belt at random, the chances of encountering even a single asteroid would be vanishingly small. This is not the dense, dangerous obstacle course of science fiction, but rather a vast, sparsely populated ocean of space where individual rocks drift in sublime isolation, separated by distances that dwarf continents. Here, in this realm of ancient silence, we encounter a different kind of cosmic wanderer than the meteors and comets we have already visited. While meteors are fleeting visitors and comets are periodic guests, asteroids are permanent residents of our solar system, the stay-at-homes who have found their gravitational sweet spot and settled in for the long haul. They are the universe's monastics, content to spin slowly in meditation, unbothered by the urgent business of planets or the dramatic displays of their cometary cousins. Each asteroid tells the story of the solar system's violent youth, when planets were still forming and collisions were commonplace. These rocky fragments are the leftover building blocks that never quite managed to assemble themselves into a planet, prevented by Jupiter's massive gravitational influence from accreting into a single large world. Instead, they remain scattered, a fossil record of planetary formation, each one carrying within its composition clues about the conditions that existed when the solar system was young. Imagine floating among these ancient wanderers, feeling the profound stillness that surrounds them. The largest asteroid series is nearly 600 miles in diameter, large enough to be classified as a dwarf planet, with enough gravity to pull itself into a roughly spherical shape. It rotates slowly on its axis once every 9 hours, its ancient surface scarred by billions of years of impacts, its interior possibly harboring a subsurface ocean beneath its rocky crust. Ceres is a world in its own right, complete with geological processes, seasonal changes as it orbits the sun, and mysteries that are only now beginning to be unraveled by human exploration. But most asteroids are far smaller than Ceres, irregular chunks of rock and metal that tumble through space like cosmic dice thrown by some primordial game. Vesta, the second largest asteroid, is shaped like a battered egg, with a massive crater at its south pole that exposes the asteroid's interior structure, giving scientists a window into the internal processes that shape these small worlds. Pallas spins at an unusual angle, possibly the result of some ancient collision that knocked it off its original rotational axis. Hygiea is dark and mysterious, composed of materials that may represent some of the most primitive matter in the solar system. Each of these asteroids follows its own unique orbit around the Sun, some taking 3 years to complete a circuit, others taking as long as 6 years. They travel at speeds of about 40,000 miles per hour relative to the Sun, but because they are all moving in roughly the same direction at roughly the same speed, their relative velocities are much lower, more like cars on a cosmic highway than bullets in a shooting gallery. When collisions do occur, they happen almost gently by cosmic standards, more like fender benders than head-on crashes. Feel the deep peace of this asteroid realm, where time moves at a different pace than on Earth. An asteroid might go millions of years without any significant change to its surface, its only companions the distant stars and the occasional passage of a spacecraft from Earth, those tiny metallic visitors that represent humanity's first tentative steps into this ancient domain. The asteroids exist in perfect gravitational equilibrium, their orbits stable for billions of years, each one finding its place in the complex dance of forces that governs the solar system. They are held in their paths not just by the Sun's gravity, but by the subtle influences of Jupiter and Mars, by the gravitational whispers of their fellow asteroids, by forces so delicate that they would be imperceptible on Earth, but which, over the vast scales of space and time, determine the fate of worlds. Some asteroids are solitary wanderers, content to spin alone through the cosmic void. Others travel in pairs or small groups, bound together by gravity's gentle touch, dancing around each other in orbits that may last for millions of years. A few asteroids have their own tiny moons, small companions that orbit their parent body like faithful dogs following their masters through space. These binary and multiple asteroid systems remind us that even in the emptiness of space, companionship can emerge, relationships can form, and the universe's tendency toward connection expresses itself on every scale. There is something profoundly moving about the constancy of the asteroids, their willingness to maintain their vigil in space regardless of what happens elsewhere in the solar system. They have witnessed the formation of the planets, the emergence of life on Earth, the rise and fall of countless species, the birth and death of civilizations. Through it all, they have continued their patient orbital dance, unchanged and unchanging, like cosmic lighthouses marking the boundaries of the inner solar system. Yet, asteroids are not merely passive observers of cosmic history. They are active participants in the ongoing story of the solar system, occasionally leaving their stable orbits to venture into the inner regions where the planets dwell. When this happens, an asteroid becomes a different kind of wanderer, a near-Earth object whose path may eventually intersect with our home planet. Most of these visits are harmless, with the asteroid passing safely by at distances measured in millions of miles. But occasionally, very rarely, an asteroid's journey brings it into direct contact with Earth, creating one of the most dramatic events in the natural world, an impact that can reshape continents, alter climates, and redirect the course of life itself. The asteroid that ended the age of dinosaurs 66 million years ago was probably no more than 6 miles across, yet its impact released energy equivalent to billions of nuclear weapons, throwing debris into the atmosphere that blocked sunlight for months and triggered a global winter that transformed the planet's ecology forever. In a sense, we owe our existence to that ancient asteroid, for without its intervention, mammals might never have had the opportunity to diversify and evolve into the countless forms that populate the Earth today, including ourselves. This reminds us that asteroids, for all their apparent constancy and stability, are also agents of change, carriers of possibility, cosmic wildcards that can alter the course of planetary evolution with a single, well-timed intervention. They embody the universe's capacity for sudden transformation, for radical change that can emerge from the most unexpected sources. But asteroids are not merely harbingers of destruction. They are also repositories of incredible wealth, not the gold and silver that motivated ancient treasure hunters, but the raw materials needed for humanity's expansion into space. Many asteroids contain concentrations of rare metals that far exceed anything found on Earth. A single metallic asteroid a mile in diameter might contain more platinum than has ever been mined on our planet, more rare Earth elements than exist in all of Earth's known deposits combined. Future generations may look upon the asteroid belt as humanity's greatest treasure trove, a source of materials that will enable the construction of vast space habitats, solar power stations, and the infrastructure needed to make our species truly spacefaring. In this sense, the asteroids that failed to become a planet billions of years ago may yet serve as the building blocks for humanity's expansion throughout the solar system. Some asteroids follow more exotic paths than their belt-dwelling cousins. The Trojans share Jupiter's orbit, clustering around 2 gravitational balance points that precede and follow the giant planet in its journey around the Sun. Like celestial courtiers attending a cosmic king, they maintain their fixed positions relative to Jupiter, while all 3 planet and asteroids orbit the Sun together in perfect synchronization. Other asteroids have been captured by planets and become moons. Phobos and Deimos, the 2 small moons of Mars, are almost certainly captured asteroids, dark and irregularly shaped, racing around the red planet in orbits so close and fast that they appear to hurtle across the Martian sky like artificial satellites. They remind us that the boundary between asteroid and moon is fluid, that the solar system is constantly evolving, constantly rearranging itself in response to gravitational influences and chance encounters. There are asteroids that venture far from the main belt, following eccentric orbits that take them close to the Sun, and then far out beyond Mars. Some of these may be extinct comets, ancient wanderers that have lost their ice and now appear as ordinary rocks, but still follow the elongated paths that speak of their cometary heritage. Others may be fragments of larger asteroids, pieces knocked loose by collisions, and now following their own independent paths through space. As we drift among these cosmic wayfarers, let yourself feel the profound patience they embody. They have been here since the solar system's birth, witnesses to everything that has transpired in our cosmic neighborhood over the past 4.6 billion years. They have seen the birth of the Sun, the formation of the planets, the emergence of life on Earth, and they will still be here long after our Sun has swelled into a red giant and then collapsed into a white dwarf star. In their endurance, asteroids teach us about the long view of existence, about the value of persistence and stability in a universe that often seems chaotic and unpredictable. They remind us that there is a place for constancy as well as change, for patient observation as well as dramatic action, for the steady maintenance of position as well as the bold exploration of new frontiers. The asteroids also embody a kind of cosmic democracy. Unlike the planets, which are clearly ranked by size and importance, asteroids exist in a vast community of rough equals. None dominates the others, none claims sovereignty over a large territory. They share the belt collectively, each following its own path while remaining part of the larger whole. They demonstrate that it is possible to maintain individual identity while participating in a greater community, to follow one's own orbital path while remaining connected to the collective dance. In their spinning motion, asteroids create their own unique rhythms. Some rotate once every few hours, others take days to complete a single turn. A few asteroids spin so rapidly that they stretch themselves into elongated shapes, their equators bulging outward from centrifugal force. Others tumble chaotically, their rotation so complex that it defies easy description. Each asteroid's spin is as unique as a fingerprint, shaped by the particular history of collisions and gravitational encounters that have marked its existence. There is poetry in the way asteroids interact with light. Those composed primarily of rock appear dark and reddish, absorbing most of the sunlight that strikes them and reflecting back only a small fraction. Metallic asteroids shine more brightly, their surfaces gleaming like cosmic mirrors. Some asteroids show variations in brightness as they rotate, revealing irregular shapes or surface features that create patterns of light and shadow as they spin. These brightness variations are often how astronomers first detect and study asteroids, reading their light curves like cosmic sheet music, interpreting the rhythms and patterns to understand the nature of these distant worlds. The gravitational influence of asteroids extends far beyond their physical boundaries. Each asteroid creates its own tiny gravitational field, and collectively, the asteroid belt exerts a measurable influence on the orbits of planets and spacecraft. NASA mission planners must account for the gravitational effects of the largest asteroids when plotting the courses of interplanetary probes, treating them as significant gravitational landmarks in the navigation of deep space. Some asteroids serve as cosmic time capsules, preserving in their interior materials that date back to the solar system's formation. These primitive asteroids, composed of carbon-rich materials and organic compounds, may hold clues to the origin of life itself. When fragments of these asteroids reach Earth as meteorites, they bring with them samples of the primordial materials from which everything in the solar system formed, including the raw ingredients that eventually gave rise to life on our planet. The study of asteroids has revolutionized our understanding of planetary formation and evolution. By analyzing their compositions, orbits, and physical properties, scientists have been able to reconstruct the early history of the solar system, understanding how the planets formed from the accretion of smaller bodies, how the giant planets migrated to their current positions, and how the asteroid belt came to be the repository of leftover planetary building blocks that it is today. As we contemplate these ancient wanderers, feel how their existence bridges the gap between the terrestrial and the cosmic, between the familiar and the alien. They are small enough to be comprehensible, yet old enough to connect us to the deepest history of our solar system. They are close enough to visit with our spacecraft, yet distant enough to represent true exploration and discovery. They embody both the accessibility and the mystery of space, the way the cosmos can be both knowable and endlessly surprising. In their collective presence, the asteroids create a kind of cosmic library, a vast archive of information about the conditions and processes that shaped the early solar system. Each asteroid is a different volume in this library, containing its own unique story written in the language of mineralogy and chemistry, orbital mechanics and surface geology. Together, they constitute one of the most important resources for understanding our cosmic heritage and our place in the larger story of planetary evolution. The asteroid belt also represents a kind of cosmic frontier, a region that humanity is only now beginning to explore in detail. The first spacecraft to visit an asteroid was Galileo, which flew past asteroids Gaspra and Ida in the 1990, providing our first close-up images of these small worlds and revealing them to be far more complex and interesting than anyone had imagined. Since then, numerous missions have visited asteroids, orbited them, landed on them, and even brought samples back to Earth, each mission adding new chapters to our understanding of these ancient wanderers. There is something deeply satisfying about the order within apparent chaos that the asteroid belt represents. While individual asteroids follow their own paths, the belt as a whole exhibits clear patterns and structures. There are gaps in the belt where Jupiter's gravity has swept away asteroids over billions of years, creating empty lanes like cosmic highways. There are families of asteroids that share similar orbits and compositions, evidence of ancient collisions that shattered larger bodies into fragments that still travel together through space, like cosmic flotillas. As we prepare to leave this realm of patient wanderers, take a moment to appreciate the profound lessons the asteroids offer. They teach us about resilience and endurance, about finding stability in motion, about maintaining individual identity while participating in collective endeavors. They show us that constancy and change can coexist, that some of the most important work in the universe is simply showing up, maintaining position, and bearing witness to the passage of time. The asteroids continue their ancient dance, each one following its own gravitational path through space, each one carrying its own cargo of cosmic history, each one a small world with its own story to tell. They will be there long after we are gone, patient sentinels marking the boundaries between the inner and outer solar system, repositories of the materials and memories from which everything we know and love originally formed. In their quiet persistence, they remind us that not all cosmic phenomena need to be spectacular to be significant, that sometimes the most profound truths are found not in dramatic explosions or brilliant displays, but in the steady, patient maintenance of position and purpose over cosmic time. They embody the universe's capacity for both change and constancy, for both individual expression and collective harmony. Rest now in this understanding, In this connection to the cosmic patience and persistence that the asteroids represent. Let their stability inform your stability, their endurance inspire your endurance, their ability to maintain their course through space, despite all the forces that might deflect them, encourage your own commitment to staying true to your path through the complexities of existence. The asteroids fade into the background as we prepare for the next stage of our journey, but their gifts remain the gifts of perspective on geological time, of appreciation for patient endurance, of understanding that some of the most important work in the universe is simply being present, maintaining position, and serving as faithful witnesses to the grand unfolding of cosmic time. Carry these gifts with you as we turn our attention from these ancient wanderers to another world entirely, as we journey to the red planet Mars, our neighboring world that has captured human imagination for generations. Chapter 5. Journey to Mars from the patient realm of asteroids, with their ancient dance of stone and metal. We now set our course for a destination that has captured human imagination like no other celestial body save the moon itself. Mars awaits us, the red planet, our planetary neighbor, the world that hangs in Earth's sky like a rust-colored beacon of possibility and mystery. As we approach this alien landscape, let yourself feel the profound significance of this moment, for you are about to visit humanity's most likely second home, the world that may someday shelter our children's children beneath its salmon-colored skies. Mars receives us with a silence that is deeper than any earthly quiet. Here, in the thin atmosphere that barely whispers across the ancient plains, sound travels differently, muffled and strange. The air pressure is less than 1% of what you know on Earth, so thin that liquid water cannot exist on the surface except in the most protected locations. Yet this is not a dead world. This is a planet with its own weather, its own seasons, its own complex geology that has been shaped by billions of years of wind and water, volcanism and impact. Feel yourself standing now on the Martian surface, your feet touching soil that has never known the footprint of any earthly creature. The gravity here is gentle, only 38% of Earth's pull, so you feel light and buoyant as though you could leap incredible distances with the slightest effort. The landscape stretches before you in shades of russet and ochre, burnt orange and deep burgundy, painted in the colors of iron oxide rust on a planetary scale that gives Mars its distinctive hue. Above you, the Martian sky presents a palette unknown on Earth. During the day, it glows with a butterscotch hue, sometimes deepening to salmon pink when dust storms stir the fine particles that perpetually hang in the thin atmosphere. This is not the deep blue of Earth's sky, born of the scattering of sunlight by thick atmosphere rich in nitrogen and oxygen. This is an alien sky, colored by different physics, different chemistry, different rules that govern how light interacts with matter in this strange new world. As the Martian day progresses, a day that lasts 24 hours and 37 minutes, surprisingly close to Earth's rhythm, you witness one of the most ethereal sights in the solar system, a Martian sunset. Here, the physics of light scattering works in reverse from what you know on Earth. As the sun descends toward the horizon, it appears smaller than it does from Earth, for Mars orbits half again as far from our star, receiving only 43% of the sunlight that bathes our home planet. But it is the colors of this sunset that take your breath away. Where Earth's sunsets paint the sky in reds and oranges, Mars offers blues and greens around the sun itself, with the rest of the sky maintaining its characteristic butterscotch glow. This alien beauty results from the fine dust suspended in the Martian atmosphere, particles that scatter red light away while allowing blue light to penetrate, creating a sunset that looks like something from a dream, a reminder that beauty takes different forms under different suns. The landscape around you tells the story of a world that was once dramatically different from what it is today. Mars is a planet of ancient waterways, dried river valleys that snake across the surface like fossil memories of flowing streams. Some of these channels are vast, larger than any river system on Earth, carved by floods that would have dwarfed any terrestrial deluge. They speak of a time when Mars had a thicker atmosphere, a warmer climate, and liquid water flowing across its surface in quantities that may have filled lakes and perhaps even shallow seas. To the north lies the massive Martian lowlands, a region so large and smooth that it may once have been the floor of a planet-spanning ocean. If this ancient sea ever existed, it would have covered nearly a third of the planet's surface, creating a world where primitive life might have emerged in warm, shallow waters under a thicker atmosphere. The shorelines of this hypothetical ocean can still be traced in the Martian topography, like bathtub rings marking the high-water mark of an ancient world. But perhaps the most awe-inspiring feature of Mars is visible even from your position on the surface: Olympus Mons, the largest volcano in the solar system. Rising 13.6 miles above the surrounding plains, this gentle giant is nearly 3 times taller than Mount Everest, with a base so broad that it covers an area larger than the state of Arizona. Standing on its lower slopes, you would not even be able to see its summit, for it would lie beyond the horizon, hidden by the planet's curvature. Olympus Mons is a shield volcano, built up over millions of years by countless eruptions of basaltic lava. Its gentle slopes, rarely steeper than a few degrees, allowed lava to flow for hundreds of miles from the central caldera, creating a mountain that is more like a vast dome than a sharp peak. This volcano may have been active as recently as a few million years ago, geologically recent in planetary terms, suggesting that Mars may still harbor internal heat and the potential for volcanic activity. The very existence of Olympus Mons tells us something profound about Mars. On Earth, volcanic hotspots create chains of mountains as the planetary crust moves over them, like the Hawaiian island chain. But Mars lacks the plate tectonics that characterize Earth. So when a volcano forms over a hotspot, it stays there, growing larger and larger over geological time, until it becomes a monster like Olympus Mons. This is what happens when a world builds up rather than spreading out, when volcanic forces focus their energy on single points for millions of years. To the east of Olympus Mons stretches Valles Marineris, the Grand Canyon of Mars, a chasm so vast that it makes Earth's Grand Canyon look like a scratch in the dirt. This enormous valley system stretches for nearly 2,500 miles across the Martian equator, roughly the distance from New York to Los Angeles, and plunges up to 4 miles deep in places. If this canyon existed on Earth, it would span the entire continental United States. Walking along the rim of Valles Marineris, you would be standing on the edge of one of the most spectacular geological features in the solar system. The canyon walls reveal layers of Martian history like the pages of a stone book, each stratum telling the story of different epochs in the planet's evolution. Some layers show evidence of ancient water activity, others reveal periods of volcanic activity or dust deposition. In the depths of the canyon, landslides larger than entire mountain ranges have carved chaotic terrains where rocks the size of city blocks lie scattered like cosmic rubble. The formation of Valles Marineris remains one of Mars' great mysteries. Unlike Earth's Grand Canyon, which was carved by flowing water over millions of years, this Martian chasm appears to have formed through tectonic stretching and collapse, possibly related to the massive volcanic activity that built the nearby Tharsis region. It may have been enlarged by water and wind erosion over geological time, but its fundamental structure speaks of internal forces that literally pulled the planet apart along this enormous fracture zone. Mars is a world of extremes in every dimension. The northern hemisphere is generally low and smooth, covered by vast plains that may once have been ocean floors. The southern hemisphere is higher and more heavily cratered, preserving the scars of the solar system's violent youth when impacts were common. This striking difference between the hemispheres, called the global dichotomy, remains one of the most puzzling features of Martian geology. Some scientists believe it resulted from a massive impact early in Mars' history, while others propose it formed through internal processes that caused the crust to thin in the north while remaining thick in the south. The polar regions of Mars offer their own unique spectacle. Unlike Earth's polar ice caps, which are composed primarily of water ice, Mars has polar caps made of both water ice and frozen carbon dioxide dry ice. During the Martian winter, the atmospheric carbon dioxide actually freezes out of the air and falls as snow, adding layers to the polar caps that can be several feet thick. As spring returns, this dry ice sublimates directly back into the atmosphere, sometimes creating geysers of gas that can shoot hundreds of feet into the air. The water ice that remains year-round at the poles is substantial if melted. It would cover the entire planet to a depth of several feet. This represents a vast reservoir of water, a potential resource for future human explorers, and possibly a refuge for any Martian life that might have adapted to the planet's current harsh conditions. Standing on the Martian surface, you become acutely aware of just how different this world is from Earth. The silence is profound with such a thin atmosphere, sound barely carries. A shout would be heard only as a whisper a few feet away. The cold is intense, with daytime temperatures near the equator sometimes rising above freezing, but nighttime temperatures plummeting to -125 degrees Fahrenheit or lower. The lack of a substantial magnetic field means that cosmic radiation bathes the surface continuously, making Mars a challenging environment for any form of life as we know it. Yet Mars is not entirely hostile to life. Recent discoveries have revealed that liquid water still exists on Mars, not on the surface but in underground aquifers and possibly in temporary flows that appear on crater walls during the warmest parts of the Martian year. These recurring slope lineae, as they are called, suggest that Mars may still have active water cycles in certain locations, creating microenvironments where life might potentially exist. The search for life on Mars has been one of the driving forces behind human exploration of the red planet. While no definitive evidence of past or present life has been found, the discoveries made by robotic explorers have been tantalizing. Mars once had conditions that could have supported life: liquid water, a thicker atmosphere, and possibly a more temperate climate. Minerals have been found that on Earth are associated with biological processes, and organic compounds have been detected in Martian rocks and soil. Perhaps most intriguingly, methane has been detected in the Martian atmosphere in concentrations that vary seasonally and geographically. On Earth, most atmospheric methane is produced by biological processes, though it can also result from geological activity. The source of Martian methane remains unknown, but its presence suggests that Mars is still an active world, whether geologically or possibly biologically. As you explore this alien landscape, you are walking in the footsteps of humanity's robotic ambassadors, the rovers and landers that have served as our eyes and hands on the Martian surface for decades. From the first successful landing of Viking 1 in 1976 to the sophisticated nuclear-powered rovers exploring the planet today, these mechanical explorers have gradually revealed Mars to be a world of incredible complexity and beauty. The images they have sent back to Earth have transformed our understanding of Mars from a simple red planet to a world with its own weather patterns. Dust storms that can engulf the entire planet, clouds that form and dissipate in daily cycles, and seasonal changes that affect everything from the polar ice caps to the color and opacity of the atmosphere. Standing in this alien landscape, You cannot help but think of the human explorers who may someday walk where you now stand in imagination. Mars represents humanity's most likely destination for interplanetary colonization, a world that, while challenging, could potentially be transformed into a second home for our species. The resources are their water locked in the polar ice and underground aquifers, carbon dioxide in the atmosphere that could be converted to breathable oxygen, minerals in the soil that could support agriculture with proper treatment. The journey to Mars would be an epic undertaking, requiring months of travel through the radiation-filled void of interplanetary space. But the human spirit that has driven us to explore every corner of our own planet will not be satisfied until we have stood on alien shores, breathed recycled air under alien skies, and looked up at an Earth that appears as just another star in the constellation of our memories. Mars has always been a mirror for human hopes and fears about our place in the universe. When early astronomers thought they saw canals on its surface, Mars became a world of intelligent beings, a reminder that we might not be alone. When robotic exploration revealed it to be apparently lifeless, Mars became a cautionary tale about planetary evolution, a world that had lost its atmosphere and water to the cold depths of space. Now, as we stand on the threshold of becoming a truly spacefaring species, Mars represents possibility once again not as a refuge from a dying Earth, but as the next step in human evolution, the next chapter in the story that began when our ancestors first looked up at the stars and wondered what lay beyond the horizon. The Red Planet teaches us about resilience and adaptation, about how worlds can change and yet endure, about the delicate balance of factors that make a planet habitable, and the cosmic forces that can alter that balance over geological time. Mars reminds us that planets are not static, unchanging worlds, but dynamic systems that evolve in response to internal and external forces, that what we see today is just one frame in a movie that has been playing for billions of years. As the alien sun sets behind you, painting the Martian sky in its otherworldly blues and greens, you feel a profound connection to this distant world that has captured human imagination for generations. Mars is our planetary neighbor, close enough to visit, different enough to challenge us, similar enough to Earth that we can imagine making it home. In the growing darkness of the Martian night, stars emerge in the thin atmosphere with a clarity unknown on Earth. Among them, you can see a blue-white star that outshines all the others. Earth, your home world, appearing from Mars as Mars appears from Earth, a wandering star in the cosmic dance, a reminder of the distances that separate worlds and the connections that bind them together in the grand symphony of the solar system. The Martian night is cold and still, but it is filled with the same stars that shine down on Earth, the same cosmic background against which both worlds play out their planetary destinies. Standing under this alien sky, you understand that Mars is not truly alien at all, but part of the same solar system family, formed from the same stellar nursery, governed by the same physical laws, participating in the same cosmic story of which Earth and all its life forms are also part. Mars waits patiently for humanity's arrival, as it has waited for billions of years, a world of ancient mysteries and future possibilities, a planetary canvas on which the next chapter of human exploration and discovery will be written. It reminds us that the universe is vast and full of worlds, each with its own character, its own story, its own gifts to offer to the cosmic conversation. Rest now in this understanding, in this connection to our planetary neighbor that represents both our past and our future, both the caution of geological change and the hope of human adaptability. Let Mars teach you about patience and persistence, about the long view of planetary time, about the courage required to venture into unknown territories and make them home. As we prepare to leave this rust-colored world and venture even farther from home, Carry with you the gifts that Mars offers: the gift of perspective on planetary scale, the gift of appreciation for the delicate conditions that make life possible, the gift of wonder at the diversity of worlds that populate our solar system. These gifts will serve you well as we expand our journey beyond individual planets to encompass entire galaxies, as we turn our attention to the great spiral wheel of stars that is our Milky Way home. Chapter 6. The whisper of the Milky Way, leaving behind the rust-colored landscapes and alien sunsets of Mars. We now embark on the most ambitious leg of our cosmic journey, expanding our consciousness to encompass not just worlds or solar systems, but an entire galaxy, our galaxy, the Milky Way, that vast spiral wheel of stars that contains everything we have ever known and billions upon billions of things we have never imagined. Let yourself float now in the perfect darkness between worlds, in that profound quiet that exists in the spaces between celestial bodies. From this vantage point, far above the plane of the solar system, you can begin to perceive the true structure of our cosmic home. What appears from Earth as a faint band of light stretching across the night sky reveals itself to be something far more magnificent, a vast spiral galaxy viewed from within, like trying to map a great city while standing in one of its neighborhoods. This darkness between the worlds is not truly empty, however. It is filled with an invisible web of gravitational influences that connect every object in the galaxy to every other object, creating a cosmic symphony of attraction and motion that has been playing for over 13 billion years. The vacuum of space itself carries the memories of ancient stellar explosions in the form of cosmic rays, high-energy particles that have been racing through the galaxy for millions of years, carrying with them the signatures of long-dead stars and distant cosmic catastrophes. Feel your perspective expanding now, your awareness growing to encompass distances that dwarf even the enormous spaces between planets. The nearest star to our Sun, Proxima Centauri, lies 4.2 light-years away, a distance so vast that light itself, traveling at 186,000 miles per second, takes over 4 years to bridge the gap. If you could travel at the speed of the fastest spacecraft humans have ever built, the journey to our nearest stellar neighbor would take over 70,000 years. To truly grasp this scale, imagine if the distance from Earth to the Sun were represented by the thickness of a sheet of paper. On this scale, the distance to Proxima Centauri would be equivalent to a stack of paper nearly 2 miles high. Yet this nearest star is so unremarkable that it cannot even be seen with the naked eye from Earth, a red dwarf star barely 1/8 the mass of our Sun, flickering weakly in the constellation Centaurus. Around this dim stellar ember orbits Proxima b, a potentially habitable world that represents humanity's nearest stepping stone to the stars, a planet where the seasons would be measured not in months, but in the subtle variations of stellar flares and magnetic storms from its temperamental host star. The space between Earth and Proxima Centauri contains not just emptiness, but the remnants of our solar system's formation, a sparse collection of interstellar dust grains, hydrogen atoms, and the occasional chunk of ancient ice and rock that has wandered far from its birthplace. These interstellar travelers carry with them chemical signatures from distant regions of the galaxy, organic molecules that formed in the atmospheres of dying stars, complex carbon compounds that assembled in the cold darkness between stellar systems. Yet Proxima Centauri is practically next door compared to the true scale of the Milky Way. Our galaxy stretches across 100,000 light-years of space, containing somewhere between 200 and 400 billion stars, each one potentially the center of its own planetary system, each one a sun that might warm worlds where other forms of consciousness look up at their own night skies and wonder about the nature of existence. The uncertainty in this stellar census reflects the galaxy's incredible diversity and the limits of our observational capabilities. Many stars exist in binary or multiple systems, locked in gravitational dances with stellar companions that can dramatically affect the formation and evolution of any planets that might orbit them. Others are surrounded by thick disks of debris left over from their formation, creating zodiacal clouds that would make their skies glow with a permanent aurora-like light. Still others have been stripped of their outer layers by close encounters with stellar neighbors, leaving behind exotic objects like white dwarf stars, neutron stars, and stellar mass black holes. Imagine yourself rising now above the galactic plane, pulled by the gentle tug of expanded awareness until you can see the Milky Way in its full glory, a great spiral galaxy with elegant arms curving outward from a central bulge that glows with the light of ancient stars. This is not a static structure, but a dynamic, rotating system where stars orbit the galactic center like cosmic dancers participating in a ballet that has been choreographed by gravity and played out over billions of years. From this elevated perspective, you can perceive the galaxy's subtle asymmetries and irregularities, evidence of its complex evolutionary history. The Milky Way is not a perfect spiral, but shows signs of past interactions with smaller galaxies that have left their marks in the form of stellar streams, warped disk edges, and disturbed gas distributions. The Sagittarius dwarf galaxy, even now being slowly torn apart by the Milky Way's tidal forces, has left a river of stars stretching completely around our galaxy, a ghostly reminder of cosmic cannibalism on galactic scales. The rotation of the galaxy reveals one of astronomy's greatest mysteries, the presence of dark matter. If the Milky Way contained only the visible stars and gas we can observe, the outer regions should rotate much more slowly than the inner regions, like planets in a solar system. Instead, the galaxy maintains what astronomers call a flat rotation curve, with outer stars moving just as fast as inner ones, as if the entire galaxy were a solid wheel rather than a gravitationally bound collection of individual objects. This observation requires the presence of approximately 5 times more dark matter than visible matter, creating an invisible scaffolding that holds the galaxy together and influences the motion of every star within it. Our Sun, along with its family of planets including Earth and Mars, resides about halfway out from the galactic center, on the inner edge of what astronomers call the Orion Arm or local spur, a minor spiral arm that branches off from one of the galaxy's major spiral features. We are neither at the crowded center, where stars pack together in ancient clusters, nor at the sparse outer edges where star formation is rare. We inhabit a middle realm, a suburban neighborhood of the galaxy where conditions are neither too extreme nor too empty for life to flourish. This location may be more significant than mere cosmic address. The galactic habitable zone theory suggests that life as we know it can only emerge in regions of the galaxy where conditions are just right, not too close to the violent center, with its supermassive black hole and frequent stellar collisions, not too far from the center where heavy elements are too scarce to form rocky planets. Our position in this cosmic Goldilocks zone may be one of the reasons why Earth was able to develop and sustain a biosphere over billions of years. The concept of the galactic habitable zone extends beyond simple chemistry to include the complex interplay of stellar evolution, supernova rates, and cosmic radiation levels. Near the galactic center, the high density of stars increases the likelihood of catastrophic events like gamma-ray bursts or nearby supernova that could sterilize planetary surfaces. The inner galaxy also experiences higher levels of cosmic rays and X-ray radiation from the central black hole, creating a challenging environment for the delicate chemical processes that support life. In the outer regions of the galaxy, a different set of challenges emerges. Stars form more slowly and from material that contains fewer heavy elements, making it difficult to build the rocky planets and complex molecules that seem necessary for life as we understand it. The lower density of stars also means longer intervals between generations of stellar evolution, slowing the pace of chemical enrichment that allows for increasing biological complexity over cosmic time. The spiral arms of the Milky Way are not rigid structures, but rather waves of density that move through the galactic disk like cosmic traffic jams, regions where gas and dust collect, and new stars are born. As our solar system orbits the galactic center, a journey that takes approximately 225 million years, we occasionally pass through these spiral arms, experiencing periods of increased cosmic radiation and gravitational disturbance that may have influenced the evolution of life on Earth. These spiral density waves represent one of the most elegant examples of large-scale organization in the universe. Unlike the fixed arms of a pinwheel, galactic spiral arms are patterns that persist even as individual stars move through them, created by the gravitational feedback between the galaxy's mass distribution and its rotation pattern. Stars spend only a few million years within the spiral arms during each galactic orbit, but while they are there, they experience enhanced gravitational interactions that can trigger star formation in nearby gas clouds and disturb the orbits of comets in outer planetary systems. Some researchers have proposed that Earth's passage through spiral arms may correlate with mass extinction events in the fossil record, suggesting that the galaxy's large-scale structure may directly influence biological evolution on individual planets. During spiral arm passages, our solar system encounters denser regions of interstellar gas and dust, increasing the likelihood of comet impacts and subtly altering Earth's climate through changes in cosmic ray bombardment that affect atmospheric chemistry and cloud formation patterns. The timing of these galactic encounters operates on scales that dwarf human history, but may have shaped the deepest patterns of life on Earth. The last time our solar system passed through a major spiral arm coincided roughly with the Permian-Triassic extinction event 250 million years ago, though establishing definitive causal relationships between galactic and terrestrial events remains an active area of research that pushes the boundaries of both astronomy and paleontology. At the very heart of our galaxy lies one of the universe's most mysterious and powerful objects, a supermassive black hole called Sagittarius, an asterisk, containing the mass of over 4 million suns compressed into a region smaller than the orbit of Mercury. This cosmic leviathan serves as the gravitational anchor for the entire galaxy, its immense pull keeping hundreds of billions of stars in their orbital dance while remaining invisible, except for the effects it has on the matter and energy that spiral into its inescapable embrace. Recent observations have allowed astronomers to watch individual stars orbit Sagittarius, an asterisk, at speeds reaching thousands of kilometers per second. Their elliptical paths, providing direct confirmation of Einstein's theories of space and time in the most extreme gravitational environment accessible to human observation. These stellar orbits stretch and compress space itself, creating gravitational lensing effects that bend light and time in ways that would have seemed like pure fantasy just decades ago. The immediate vicinity of the central black hole represents a cosmic laboratory where the fundamental forces of nature operate under conditions that can never be reproduced on Earth. Matter falling into Sagittarius, an asterisk, reaches temperatures of billions of degrees, emitting X-rays and gamma rays that illuminate the surrounding space in wavelengths invisible to human eyes, but detectable by our most sophisticated instruments. The black hole's rotation drags spacetime itself around in its wake, creating a cosmic whirlpool that extends its influence far beyond the event horizon. Paradoxically, this region of ultimate gravitational imprisonment also serves as one of the galaxy's most prolific sources of energy. The accretion disk surrounding Sagittarius, an asterisk, converts gravitational potential energy into electromagnetic radiation, with an efficiency that surpasses nuclear fusion by orders of magnitude. Jets of high-energy particles launched from the vicinity of the black hole extend thousands of light-years above and below the galactic plane, creating vast bubbles of hot gas that were only discovered in the past decade through gamma-ray observations. Around this central black hole, the galactic bulge glows with the light of ancient red and yellow stars, stellar veterans that formed when the galaxy was young, and have watched the slow evolution of the Milky Way from a chaotic collection of gas clouds into the elegant spiral structure we see today. These old stars are the galaxy's memory keepers, their light carrying information about cosmic conditions that existed billions of years before the Earth was even a possibility. The stars of the galactic bulge tell a story of cosmic archaeology written in starlight. Their chemical compositions preserve records of the early universe when heavier elements were rare, when the first generations of massive stars lived brilliant lives before exploding as supernova that scattered the seeds of future complexity throughout the galaxy. Some of these ancient stars contain almost no heavy elements beyond hydrogen and helium, representing direct links to cosmic conditions that existed within the first billion years after the Big Bang. These stellar fossils orbit the galactic center in complex three-dimensional patterns that reflect the violent early history of our galaxy's formation. Unlike the orderly rotation of the galactic disk, the bulge stars move in chaotic, highly elliptical orbits that carry them far from the galactic plane before plunging back toward the central regions. This orbital architecture suggests that the bulge formed through a series of galactic collisions and mergers that occurred billions of years ago, when the Milky Way was assembling itself from smaller proto-galactic fragments. The galactic bulge also contains some of the galaxy's most exotic stellar objects, including RR Lyrae variable stars that pulse with regular rhythms like cosmic lighthouses, allowing astronomers to measure distances and ages with remarkable precision. Planetary nebulae in the bulge, the beautiful death shrouds of sun-like stars, create some of the most spectacular displays in the galaxy, as their central white dwarf stars ionize the surrounding gas with intense ultraviolet radiation, painting cosmic roses and butterflies across thousands of astronomical units. The spiral arms themselves are painted with the brilliant blue and white light of young, massive stars, stellar giants that burn bright and die young, living for only a few million years before exploding as supernova that scatter the heavy elements necessary for planet formation and life across the galactic medium. These stellar fireworks serve as the galaxy's recycling system, taking the simple hydrogen and helium that filled the early universe and transforming them into the complex elements that make up rocky planets, liquid water, and living beings. The most massive of these stars can exceed 100 times the mass of our Sun, burning through their nuclear fuel so rapidly that they barely have time to form stable planetary systems, before ending their lives in spectacular explosions that briefly outshine entire galaxies. These hypergiant stars represent cosmic extremes, objects so massive and luminous that they push the boundaries of stellar physics. Their surfaces so hot that they emit most of their energy in ultraviolet wavelengths that would be instantly lethal to any form of life that dared approach them. Yet even these stellar monsters play crucial roles in the galaxy's ecosystem, serving as cosmic foundries where elements heavier than iron are forged in the final moments before stellar collapse. The gold in your jewelry, the silver in your electronics, The uranium in nuclear reactors, all of these elements were created in the extreme conditions that exist for mere seconds during supernova explosions. When stellar cores collapse with such violence that protons and neutrons are compressed together into atomic nuclei, that would be impossible to create under any other natural circumstances. The shock waves from these stellar explosions propagate through the interstellar medium at speeds of thousands of kilometers per second, compressing nearby gas clouds and triggering the formation of new generations of stars. This creates a cosmic cycle of stellar death and birth that has been operating for billions of years, gradually enriching the galaxy with the heavy elements necessary for complex chemistry, and ultimately, for life itself. Between the stars lies the interstellar medium, vast clouds of gas and dust that serve as the raw material for future star formation. Some of these clouds are dark and cold, visible only as silhouettes against the background starlight. Others glow with their own light, energized by nearby hot stars into magnificent nebulae that paint regions of space in reds and blues and greens, creating cosmic artwork on scales that dwarf anything terrestrial imagination can conceive. The interstellar medium represents one of the most dynamic and chemically active environments in the galaxy. Despite its incredibly low density, typically containing only 1 atom per cubic centimeter, a vacuum far more perfect than anything achievable in terrestrial laboratories. Within this tenuous medium, complex molecules form and evolve through processes that operate over millions of years, creating cosmic chemistry sets where amino acids, sugars, and other organic compounds assemble in the cold darkness between stars. The discovery of complex organic molecules in interstellar clouds has revolutionized our understanding of how life's building blocks are distributed throughout the galaxy. Water, methanol, formaldehyde, and even amino acids have been detected in star-forming regions, suggesting that the molecular foundations of biology are not rare accidents but common products of cosmic chemistry that occur wherever conditions permit the assembly of complex carbon-based compounds. Radio telescopes have revealed that the interstellar medium resonates with the spectral signatures of dozens of different molecules, creating a cosmic symphony of chemical transitions that allows astronomers to map the three-dimensional structure of gas clouds and track the flow of material between stars. Each molecule emits and absorbs light at characteristic wavelengths, creating spectral fingerprints that reveal temperature, density, velocity, and chemical composition across vast regions of space. The magnetic fields threading through the interstellar medium add another layer of complexity to this cosmic ecosystem, organizing the flow of gas and dust along invisible highways that can stretch for hundreds of light years. These magnetic field lines, generated by the motion of charged particles through the galaxy's gravitational field, serve as conduits for cosmic rays and provide the framework along which star formation proceeds, creating the elongated structures and filamentary patterns observed in many star-forming regions. The Eagle Nebula, with its towering pillars of gas and dust where new stars are being born, stretches across regions of space that would take light several years to cross. The Orion Nebula, visible to the naked eye as a fuzzy star in the constellation of the Hunter, is actually a stellar nursery containing enough material to create thousands of new suns, each potentially surrounded by its own family of planets. These star-forming regions reveal the incredible violence and beauty inherent in stellar birth. The Orion Nebula, located just 1,344 light-years from Earth, serves as our nearest example of massive star formation in action. At its heart lies the Trapezium Cluster, a tight grouping of young, hot stars whose intense radiation and stellar winds have carved out a cavity in the surrounding gas cloud, creating one of the most photogenic objects in the night sky. The physics of star formation involves a delicate balance between gravitational collapse and the various forces that resist it: thermal pressure, magnetic pressure, and turbulence that keeps gas clouds stirred and prevents them from settling into gravitationally bound structures. When this balance tips in favor of gravity, typically triggered by shock waves from nearby supernova explosions or collisions between gas clouds, the result is a cascade of stellar birth that can create entire star clusters containing thousands of new suns. Within these stellar nurseries, the process of planetary system formation begins almost immediately. Circumstellar disks of gas and dust, the raw material from which planets form, are ubiquitous around newborn stars, suggesting that planetary systems are a natural byproduct of star formation rather than rare accidents. The Hubble Space Telescope has revealed these protoplanetary disks in exquisite detail, showing how dust grains slowly aggregate into larger and larger objects, eventually forming the asteroids, comets, and planets that populate mature stellar systems. The chemical composition of these protoplanetary disks reflects the long history of galactic chemical evolution, with each generation of stars inheriting a richer mixture of heavy elements from the stellar explosions that preceded them. This gradual chemical enrichment has profound implications for the types of planets and the potential for life in different regions of the galaxy and at different epochs in cosmic history. These star-forming regions remind us that the galaxy is not a finished work, but an ongoing creation, a cosmic symphony that is still being composed. Every year, our galaxy creates new stars at the rate of about one solar mass, enough material to build a star like our Sun. Each of these stellar births represents a new beginning, a new possibility for planets, and perhaps for life itself. The rate of star formation in the Milky Way has not remained constant throughout its history. During the galaxy's youth, when gas reservoirs were more abundant and galactic collisions more frequent, stars formed at rates perhaps 10 times higher than we observe today. This early epoch of vigorous star formation created most of the galaxy's stellar mass and established the basic architecture of spiral arms and central bulge that we see today. As the galaxy has aged, its star formation rate has gradually declined as available gas has been consumed and expelled by stellar winds and supernova. The Milky Way is now in a more mature phase of its evolution, forming stars at a more sedate pace while slowly consuming the remaining reserves of interstellar gas. Astronomical observations suggest that our galaxy may continue forming stars for another 10-20 billion years before exhausting its fuel supply and entering a period of stellar decline. This long-term perspective on galactic evolution raises profound questions about the future of life and consciousness in the cosmos. As star formation rates decline and the galaxy's population shifts towards smaller, longer-lived stars, the opportunities for new planetary systems and the emergence of life will gradually diminish. Yet the stars that are forming today, including many red dwarf stars with lifetimes measured in hundreds of billions of years, will continue shining long after our Sun has exhausted its nuclear fuel and become a white dwarf star. Feel yourself drifting now through this cosmic ecosystem, sensing the deep connections that bind everything together. The iron in your blood was forged in the nuclear furnaces of massive stars that lived and died before the Sun was born. The calcium in your bones was created in stellar explosions that scattered their enriched material across the galaxy, contributing to the slow alchemy that would eventually allow rocky planets and complex chemistry to emerge. This cosmic recycling operates on multiple scales simultaneously, from the nuclear fusion processes in stellar cores that transmute hydrogen into heavier elements, to the galactic scale circulation patterns that distribute stellar ejecta throughout the interstellar medium. Every atom in your body has a cosmic history that spans billions of years and may have been part of dozens of different stellar systems before arriving at Earth. The oxygen you breathe was created in the cores of massive stars at least 8 times more massive than the Sun, while the carbon in your DNA was forged in smaller stars during their final helium-burning phases. The nitrogen in your amino acids originated in the outer layers of dying stars that shed their atmospheres as planetary nebulae, while trace elements like copper and zinc were synthesized during supernova explosions that released more energy in seconds than the Sun will produce over its entire 10 billion-year lifetime. You are made of galactic recycling, your body composed of elements that have traveled for billions of years through the cosmic medium, participating in countless stellar cycles of birth and death and rebirth. The atoms that make up your consciousness have been part of gas clouds and planetary atmospheres, stellar cores and comet nuclei, gradually working their way through the galactic ecosystem, until they came together in the particular arrangement that allows you to exist, to think, to wonder about your place in this vast cosmic web. This perspective transforms our understanding of identity and belonging from a terrestrial to a cosmic scale. We are not separate from the universe, but literally made of it, temporary arrangements of cosmic material that have achieved the extraordinary ability to contemplate their own origins. The same physical processes that created galaxies, stars, and planets have also created the neural networks in our brains that allow us to appreciate beauty, seek truth, and experience wonder at the majesty of creation. The elements flowing through our bodies connect us not only to our cosmic past but to our cosmic future as well. The calcium in our bones will eventually return to the interstellar medium, perhaps to be incorporated into future planetary systems and possibly future forms of life. The iron in our blood may someday flow through the veins of beings we cannot imagine, living on worlds that have not yet formed around stars that have not yet been born. The Milky Way teaches us about cycles, how matter flows from interstellar clouds into stars, from stars into planets, from planets back into the cosmic medium through stellar winds and supernova explosions, and from there into new generations of stars and worlds. Nothing is ever truly lost in this cosmic recycling system. Everything is constantly being transformed, reorganized, given new opportunities to participate in the ongoing creation of complexity and beauty. These cycles operate on vastly different timescales, from the rapid nuclear reactions in stellar cores that occur in milliseconds, to the slow orbital motions of stars around the galactic center that require hundreds of millions of years to complete. The interplay between these different temporal rhythms creates the complex, hierarchical structure we observe in the galaxy today, where small-scale processes aggregate into larger patterns that persist for cosmological ages. Understanding these cosmic cycles has profound implications for how we view our relationship to the natural world. The environmental cycles that sustain life on Earth, the water cycle, the carbon cycle, the nitrogen cycle, are themselves embedded within much larger galactic cycles that operate over billions of years. The stability that allows these terrestrial cycles to function depends ultimately on the galaxy's ability to maintain steady rates of star formation and chemical enrichment over cosmic time. Our galaxy also teaches us about time scales that dwarf human experience. The light reaching us from the most distant stars in the Milky Way began its journey when complex life was just beginning to emerge on Earth. The galaxy has rotated only about 20 times since its formation, 13.6 billion years ago. In the context of galactic time, the entire history of life on Earth from the first primitive cells to the present moment represents just a brief chapter in the much longer story of cosmic evolution. This perspective on cosmic time challenges our ordinary notions of permanence and change. Mountains that seem eternal by human standards are ephemeral features when viewed against the backdrop of galactic evolution. The continents drift across Earth's surface. The climate fluctuates between ice ages and warm periods. Species emerge and go extinct, all while our solar system completes less than 1% of a single orbit around the galactic center. Yet within this vast temporal context, we find evidence of the universe's tendency toward increasing complexity and organization. The early galaxy was a simpler place, composed primarily of hydrogen and helium gas with only trace amounts of heavier elements. But stellar nucleosynthesis has gradually enriched the galactic medium with carbon and oxygen, silicon and iron, nitrogen and phosphorus, all the elements necessary for rocky planets, liquid water, and organic chemistry. The history of galactic chemical evolution reads like a cosmic cookbook, with each generation of stars adding new ingredients to the recipe for complexity. The first stars contained virtually no elements heavier than lithium, yet their explosive deaths seeded the interstellar medium with carbon, oxygen, and other elements essential for the next generation of stellar and planetary formation. This process of cosmic cooking has been going on for over 13 billion years, gradually increasing the metallicity astronomers term for all elements heavier than hydrogen and helium of the interstellar medium, from essentially zero to its current level of about 2% by mass. This may seem like a small fraction, but it represents the difference between a universe capable only of making stars and a universe capable of making planets, oceans, atmospheres, and life. This cosmic enrichment process has created what astronomers call the galactic habitable zone, a region of the Milky Way where conditions are just right for the formation of planetary systems capable of supporting life. Too close to the galactic center, and the radiation environment becomes too harsh, with frequent supernova and high levels of cosmic rays that would sterilize planetary surfaces. Too far from the center, and there are too few heavy elements to form rocky planets and complex molecules. But in the middle regions where we find ourselves, conditions have been stable enough for billions of years to allow the slow processes of planetary formation, atmospheric evolution, and biological development to unfold. Our location in the galaxy may be one of the reasons why life was able to emerge and flourish on Earth, why we exist to contemplate our cosmic home from this particular vantage point in space and time. The concept of galactic habitable zones has become increasingly sophisticated as astronomers have learned more about the complex factors that influence planetary habitability. Beyond simple chemical abundance, factors like supernova rates, gamma-ray burst frequency, stellar encounter rates, and tidal effects from the central black hole all play roles in determining whether a particular region of the galaxy is conducive to the long-term stability required for biological evolution. Recent research has also revealed that the galactic habitable zone has evolved over time as the galaxy itself has aged and changed. Early in the Milky Way's history, the zone may have been much smaller and located closer to the galactic center, gradually expanding outward as stellar nucleosynthesis enriched the outer regions with heavy elements. This temporal evolution of habitability suggests that the emergence of life may be intimately connected to the galaxy's own evolutionary history. The Milky Way is not alone in the universe. It is part of a small cluster of galaxies called the Local Group, which includes our large neighbor Andromeda, several smaller spiral and elliptical galaxies, and dozens of dwarf galaxies that orbit around the larger members like cosmic satellites. The nearest of these, the Large and Small Magellanic Clouds, are visible from Earth's southern hemisphere as fuzzy patches of light that early navigators used as signposts in the southern sky. From our elevated perspective, you can see these galactic companions as separate island universes, each with its own population of stars, its own history of formation and evolution, its own possibilities for planets and life. The Andromeda Galaxy, in particular, appears as a magnificent spiral similar to our own Milky Way, but slightly larger, containing perhaps 1 trillion stars compared to our few hundred billion. The local group represents a gravitationally bound system about 10 million light-years across, containing more than 80 known galaxies of various sizes and types. Most of these are small dwarf galaxies containing only millions or billions of stars, compared to the hundreds of billions found in large spiral galaxies like the Milky Way and Andromeda. Yet these seemingly insignificant companions play crucial roles in galactic evolution, serving as repositories of dark matter and sources of fresh gas that can fuel continued star formation in their larger neighbors. The gravitational interactions between local group members have profoundly influenced their individual evolutionary histories. The Milky Way's gravitational influence extends far beyond the visible galaxy, stretching across millions of light-years to influence the motions and star formation patterns of neighboring dwarf galaxies. Some of these smaller systems are being slowly torn apart by tidal forces, leaving streams of stars that trace their orbital paths around our galaxy. These stellar streams serve as archaeological evidence of past galactic encounters, allowing astronomers to reconstruct the complex history of mergers and interactions that have shaped the local group over billions of years. The Sagittarius Stream, created by the ongoing disruption of the Sagittarius dwarf galaxy, completely encircles the Milky Way and provides direct evidence that our galaxy continues to grow through the accretion of smaller systems. Remarkably, Andromeda and the Milky Way are approaching each other, drawn together by their mutual gravitational attraction across the 2.5 million light-years that currently separate them. In approximately 4.5 billion years, these two great spiral galaxies will collide and merge, creating a new, larger elliptical galaxy that astronomers have already nicknamed Milkomeda. This future collision will be a dance of cosmic proportions, with both galaxy structures dramatically altered but most individual stars likely surviving the event, simply finding themselves rearranged into new orbital patterns around a combined galactic center. Computer simulations of this future galactic collision reveal a complex choreography of gravitational interactions that will unfold over several billion years. The first close encounter will occur in about 4.5 billion years, sending shock waves through both galaxies and triggering massive bursts of star formation as gas clouds collide and compress. The galaxies will then separate briefly, before falling back together in a series of increasingly intimate passes that will ultimately result in their complete merger. During this cosmic collision, the night sky as seen from Earth, if our planet still exists, will be dramatically transformed. Andromeda will grow larger and larger in the sky as the galaxies approach, eventually dominating the celestial sphere with its spiral arms and bright central bulge. The collision itself will create spectacular displays of stellar fireworks as gas clouds collide and form new stars at rates far exceeding anything seen in the present-day galaxy. Yet despite the violence implied by the term galactic collision, the actual event will be remarkably gentle on the scale of individual stars and planetary systems. The vast distances between stars mean that direct stellar collisions will be extremely rare, though gravitational perturbations may disrupt some planetary orbits and alter the trajectories of comets and asteroids throughout both galaxies. This coming galactic merger reminds us that even structures as vast and seemingly permanent as galaxies are dynamic, evolving systems. The universe is not a static collection of objects but a living, breathing cosmos where everything is in motion, everything is connected, everything is part of ongoing processes of growth, change, and transformation. As you float in contemplation of our galactic home, let yourself feel the profound sense of belonging that comes from understanding your place in this vast cosmic structure. You are not an outside observer of the Milky Way, you are an integral part of it, a temporary arrangement of galactic material that has achieved the remarkable ability to contemplate its own existence. Your consciousness is the galaxy becoming aware of itself, the universe developing the capacity for self-reflection through the emergence of minds capable of wonder and understanding. This realization transforms our understanding of consciousness from a purely biological phenomenon to a cosmic one. The same processes that created the Milky Way's spiral structure have also created the neural networks that allow us to appreciate that structure. The gravity that holds galaxies together operates on the same principles as the electromagnetic forces that enable thoughts to flow through our brains. We are not separate from the cosmos but expressions of it, temporary patterns in the cosmic web that have achieved the extraordinary capacity for self-awareness. The emergence of consciousness in the universe represents a phase transition as significant as the formation of the first stars or the first galaxies. Through consciousness, the universe has developed the ability to observe itself, to understand its own structure and evolution, to appreciate its own beauty and complexity. We are the cosmos becoming conscious, the galaxy awakening to its own existence through billions of years of evolution that led from simple hydrogen clouds to thinking beings capable of cosmic perspective. The stars that make up the Milky Way's spiral arms are not randomly distributed, but organized into communities and associations that reflect their common origins. Star clusters, both the loose associations called open clusters and the densely packed globular clusters that orbit the galactic halo, preserve information about the conditions that existed when their member stars formed. Some of these clusters are among the oldest objects in the galaxy, containing stars that have been shining since shortly after the Milky Way itself began to take shape. Open star clusters represent stellar nurseries, where dozens to thousands of stars formed from the same giant molecular cloud within a relatively brief period of cosmic time. The Pleiades, visible to the naked eye as a tight grouping of blue-white stars in the constellation Taurus, formed just 100 million years ago and still retains the wisps of gas and dust from its birth cloud. These young clusters gradually disperse as gravitational interactions with passing gas clouds and other stellar systems alter the orbits of their member stars, eventually spreading them throughout the galactic disk. The globular clusters in particular serve as fossil remnants of the galaxy's youth, when it was a more chaotic place filled with colliding gas clouds and rapid star formation. These spherical concentrations of ancient stars orbit the galactic center in highly elliptical paths that take them far above and below the main galactic disk, like cosmic lighthouses, marking the three-dimensional extent of our galaxy's gravitational influence. Each globular cluster contains hundreds of thousands to millions of stars packed into spherical regions only a few dozen light-years across stellar densities, thousands of times higher than found in our solar neighborhood. If Earth orbited a star in the center of a globular cluster, our night sky would be ablaze with thousands of stars brighter than Venus, making darkness virtually unknown and possibly preventing the development of astronomy as we know it. The study of globular clusters has revolutionized our understanding of stellar evolution and galactic formation. Because all stars in a cluster formed at the same time from the same material, They provide natural laboratories for testing theories of how stars age and evolve. The most massive stars in ancient clusters have long since exhausted their nuclear fuel and evolved into white dwarfs, neutron stars, or black holes, while the smallest red dwarf stars remain virtually unchanged from their formation billions of years ago. Within the galactic disk itself, the spiral arms serve as highways for cosmic processes, channels along which gas flows inward toward the galactic center, while shock waves from stellar winds and supernova drive enriched material outward. This circulation pattern ensures that the products of stellar nucleosynthesis, the heavy elements essential for planet formation and life, are distributed throughout the galaxy, seeding new regions with the materials necessary for the next generation of star and planet formation. The spiral arm structure creates a complex ecosystem of stellar populations, each occupying distinct ecological niches within the galactic environment. The youngest, most massive stars concentrate along the inner edges of spiral arms where gas compression triggers active star formation, while older stellar populations migrate outward as they age, creating gradients in stellar age and chemical composition that reflect the dynamic nature of galactic evolution. This stellar ecology extends to the types of planetary systems that form in different galactic environments. Stars born in the dense, metal-rich regions near spiral arms tend to form planetary systems with higher abundances of rocky planets, while stars forming in the sparse regions between arms may produce systems dominated by gas giants, or may fail to form planets altogether due to insufficient heavy element abundance. The magnetic field of the Milky Way, though invisible to our eyes, plays a crucial role in organizing galactic structure and mediating the flow of cosmic rays through interstellar space. This vast magnetic web, generated by the motion of charged particles through the galaxy's gravitational field, helps to channel the flow of gas and dust along the spiral arms while providing partial protection for planetary systems from the most energetic cosmic radiation. The galactic magnetic field operates on scales that dwarf terrestrial magnetism by factors of trillions, yet maintains organized structures that persist for millions of years. These magnetic field lines serve as cosmic highways for charged particles, creating preferential paths for cosmic ray propagation, and influencing the formation of stellar jets and outflows from young stars. Recent observations have revealed that the magnetic field strength varies dramatically throughout the galaxy, reaching peak intensities in star-forming regions where magnetic pressure can rival gravitational forces in shaping the dynamics of gas clouds. The interaction between magnetic fields and turbulent gas motions creates a complex web of magnetohydrodynamic processes that influence everything from the rate of star formation to the structure of planetary magnetospheres. Understanding these magnetic processes has become crucial for predicting how galactic environments might affect the habitability of exoplanets, as magnetic field configurations can either shield planetary atmospheres from cosmic ray bombardment or channel high-energy particles directly into planetary surfaces. Recent discoveries have revealed that our galaxy possesses a complex ecosystem of invisible dark matter, a mysterious substance that outweighs all the visible stars and gas by a factor of at least 5 to 1. This dark matter forms a vast halo around the visible galaxy, providing the gravitational scaffolding that holds the Milky Way together and influences the motion of every star within it. Though we cannot see dark matter directly, its gravitational effects are written in the orbital velocities of stars, in the structure of the spiral arms, in the way gas flows through the galactic medium. The dark matter halo extends far beyond the visible edge of the Milky Way, reaching out perhaps 300,000 light-years from the galactic center 3 times the diameter of the luminous disk. Within this vast, invisible structure, smaller clumps and substructures of dark matter create a complex gravitational landscape that influences the formation and evolution of stellar systems throughout the galaxy. Computer simulations suggest that the dark matter halo contains thousands of dense subclumps, remnants of ancient galactic mergers that have been gradually incorporated into the Milky Way's gravitational embrace. These dark matter substructures may be responsible for some of the asymmetries observed in stellar streams and gas distributions, acting as gravitational perturbations that stir and heat the galactic disk over billions of years. The presence of dark matter reminds us that the universe contains far more than meets the eye, that our understanding of cosmic structure is still evolving, that there are fundamental aspects of reality that remain mysterious despite centuries of scientific investigation. The Milky Way serves as our laboratory for studying these cosmic mysteries, a place where we can observe the effects of dark matter and dark energy, test our theories of stellar evolution and galactic dynamics, and gradually piece together a more complete picture of how the universe works on the largest scales. The search for dark matter has become one of the most important quests in modern physics, involving underground detectors, particle accelerators, and space-based telescopes, all working to identify the nature of this invisible cosmic constituent. Some theories propose that dark matter consists of exotic particles left over from the Big Bang, while others suggest modifications to our understanding of gravity itself. The resolution of this mystery will likely revolutionize our comprehension of fundamental physics and cosmology. At the same time, the galaxy serves as our connection to the even larger structures that organize the cosmic web. The Milky Way and its local group neighbors are themselves part of a much larger structure called the Virgo supercluster, a collection of thousands of galaxies bound together by gravity and spanning over 100 million light-years of space. This supercluster is itself part of an even larger structure called Laniakea, which contains over 100,000 galaxies and represents our cosmic address in the hierarchy of structures that organize matter on the largest scales. Laniakea, whose name means immense heaven in Hawaiian, represents one of the largest known structures in the observable universe, stretching across more than 500 million light-years and containing the mass of 100 million billion suns. Within this vast cosmic web, galaxies flow along invisible highways of dark matter, following gravitational currents that have been shaped by billions of years of cosmic evolution. The discovery of these cosmic megastructures has transformed our understanding of the universe's large-scale organization, revealing that galaxies are not randomly scattered through space, but organized into a vast network of filaments, sheets, and voids that resembles a cosmic spider web. The Milky Way's position within this web influences its evolution, as gravitational interactions with neighboring structures affect the galaxy's rotation, star formation rate, and overall stability. Understanding our place in this cosmic hierarchy provides a profound perspective on both our cosmic significance and our cosmic humility. We are part of structures so vast that light takes millions of years to cross them, yet we are also made of the same fundamental particles and governed by the same physical laws that operate throughout the observable universe. We are simultaneously infinitesimal and essential, temporary and eternal, local and universal. This perspective challenges traditional notions of scale and importance, revealing that significance in the universe is not determined by size alone but by complexity, organization, and the capacity for information processing and awareness. A human brain, though tiny compared to a galaxy, contains more organized information and exhibits more complex behavior than most astronomical objects, representing a different kind of cosmic achievement than the simple aggregation of mass and energy. The study of our galaxy has also revealed the profound role that chance and contingency play in cosmic evolution. The Milky Way's current structure and properties resulted from billions of years of complex interactions between gravity, stellar evolution, gas dynamics, and magnetic fields. Small changes in initial conditions billions of years ago might have led to a very different galactic environment, one perhaps less conducive to the formation of planetary systems capable of supporting life. The sensitive dependence of galactic evolution on initial conditions illustrates what scientists call the butterfly effect operating on cosmic scales. The precise timing of early galactic mergers, the distribution of dark matter substructures, the initial rotation rate of the proto-galaxy, all of these factors could have led to dramatically different outcomes that might have prevented the emergence of the stable, metal-enriched environment that allowed our solar system to form and life to evolve on Earth. This recognition of cosmic contingency brings with it both humility and responsibility. The conditions that allowed our galaxy to evolve into a place where life could emerge and flourish were not inevitable. They were the result of a particular sequence of cosmic events that might easily have unfolded differently. This makes our existence not just improbable but precious, a gift that emerges from the interplay of physical laws and cosmic history. The preciousness of our cosmic situation extends beyond mere statistical improbability to encompass the extraordinary complexity and beauty that have emerged from billions of years of galactic evolution. The Milky Way is not just a collection of stars and gas, but a self-organizing system that has developed intricate structures, complex chemical cycles, and ultimately the capacity for self-awareness through the emergence of conscious beings like ourselves. The Milky Way also teaches us about the deep connections between the very large and the very small. The spiral structure that we observe on galactic scales emerges from the gravitational interactions of billions of individual stars, each following its own orbital path, yet collectively creating patterns that persist for hundreds of millions of years. The chemical evolution of the galaxy depends on nuclear processes occurring in stellar cores, microscopic reactions that collectively determine the composition of entire galactic regions. This interplay between different scales of organization, from subatomic particles to galactic superclusters, illustrates one of the most profound features of cosmic evolution: the way that simple rules operating at one level can give rise to complex emergent properties at higher levels of organization. The galaxy, as a whole, exhibits behaviors and characteristics that cannot be predicted from studying individual stars in isolation, just as consciousness exhibits properties that cannot be understood by studying individual neurons alone. The concept of emergence, the way complex systems develop properties that transcend their individual components, appears throughout galactic astronomy. Star formation emerges from the gravitational collapse of gas clouds. Spiral structure emerges from density waves propagating through stellar orbits. Chemical complexity emerges from successive generations of stellar nucleosynthesis. Each level of organization creates new possibilities that did not exist at lower levels, leading to an ongoing process of cosmic creativity that continues to generate novelty and complexity. This emergent complexity extends to the phenomenon of life itself, which represents an entirely new category of cosmic organization that emerged when molecular chemistry achieved sufficient complexity to support self-replication and evolution. The transition from non-living to living systems represents one of the most dramatic phase transitions in cosmic history, comparable to the formation of the first atoms or the first stars. As you contemplate the vast spiral wheel of our galactic home, feel how it serves as both a physical structure and a metaphysical symbol. The Milky Way represents the universe's capacity for self-organization, its tendency to create structure and beauty from chaos, its ability to generate complexity and consciousness from simple beginnings. It embodies the cosmic processes that connect the birth of the universe in the Big Bang to the emergence of life and mind in contemporary cosmos. The spiral structure itself serves as a powerful symbol of cosmic creativity and continuity. Unlike rigid geometric forms, spirals suggest growth, development, and the dynamic interplay between stability and change that characterizes all living systems. The golden ratio that appears in galactic spiral arms also appears in nautilus shells, flower petals, and human DNA, suggesting deep mathematical principles that operate across all scales of cosmic organization. The galaxy's rotation creates a cosmic rhythm that connects all of its constituent parts in a vast choreography of motion and time. Every star, every gas cloud, every dark matter particle participates in this galactic dance, following orbital patterns that link individual destinies to the collective evolution of the whole system. This cosmic rhythm operates on timescales that encompass the entire history of complex life on Earth, suggesting that biological evolution itself may be subtly synchronized with larger galactic cycles. The galaxy also serves as a reminder of our responsibility as conscious beings in an evolving universe. We are not passive observers of cosmic evolution but active participants in it, capable of understanding galactic processes, influencing our local environment, and potentially spreading life and consciousness to other worlds within our galactic neighborhood. The same cosmic processes that created the heavy elements in our bodies have also created the capacity for understanding, appreciation, and stewardship that defines human consciousness at its best. This responsibility extends beyond our immediate terrestrial environment to encompass our role as potential gardeners of galactic evolution. As we develop the technological capability to travel between stars and potentially seed life on other worlds, we become agents of cosmic evolution, participants in the galaxy's ongoing development of complexity and consciousness. The choices we make in the coming centuries and millennia may influence the future evolution of life and intelligence throughout our galactic neighborhood. The concept of cosmic responsibility also applies to our treatment of information and knowledge. As possibly the only conscious observers in our local galactic region, we serve as repositories of cosmic memory, preserving and transmitting the accumulated wisdom of billions of years of cosmic evolution. The stories we tell about the universe, the knowledge we preserve about galactic structure and evolution, the values we develop through cosmic perspective, all of these become part of the galaxy's ongoing development of self-awareness. In the spiral arms of the Milky Way, star formation continues to create new suns, new planetary systems, new possibilities for the emergence of life and consciousness. Some of these new worlds may already harbor primitive life forms taking their first tentative steps toward complexity and awareness. Others may develop advanced civilizations millions of years in the future, adding their own voices to the cosmic conversation that we have only recently joined. The statistical arguments for extraterrestrial life become compelling when viewed against the backdrop of galactic evolution. With hundreds of billions of stars in our galaxy alone, and with planetary systems appearing to be common byproducts of star formation, the probability that Earth hosts the only life in the Milky Way seems vanishingly small. The discovery of extremophile organisms thriving in the most hostile environments on Earth has expanded our conception of habitable conditions, suggesting that life might emerge wherever liquid water and energy sources coexist for sufficient periods of time. The search for other life in our galaxy has become one of the most profound scientific endeavors of our time, driven by the realization that the same cosmic processes that created life on Earth have been operating throughout the Milky Way for billions of years. The discovery of thousands of exoplanets, worlds orbiting other stars, has revealed that planetary systems are common throughout the galaxy, suggesting that the raw materials for life are widely distributed in cosmic space. Recent discoveries of potentially habitable exoplanets within our galactic neighborhood have intensified speculation about the possibility of detecting signs of life beyond Earth. Planets like Proxima Centauri b, TRAPPIST-1e, and Kepler 452b orbit within the habitable zones of their host stars, where liquid water could potentially exist on planetary surfaces. Advanced telescopes currently under development may soon be capable of analyzing the atmospheric compositions of these distant worlds, searching for chemical signatures that could indicate biological activity. The search for extraterrestrial intelligence SETI represents an even more ambitious attempt to detect not just life, but conscious, technologically capable life elsewhere in the galaxy. Radio telescopes scan the sky for artificial signals that might indicate the presence of alien civilizations, while optical searches look for laser pulses or other technological signatures that could reveal intelligent activity around distant stars. Whether we are alone in our galaxy or part of a vast community of conscious beings remains one of the great open questions of our time. But regardless of the answer, the search itself transforms us, expanding our sense of cosmic citizenship and responsibility. We become not just inhabitants of Earth or even the solar system, but citizens of the Milky Way, participants in galactic evolution, carriers of the universe's capacity for self-awareness and understanding. If we are alone, then we bear the profound responsibility of being the galaxy's only conscious observers, the sole repositories of cosmic knowledge and appreciation. If we are part of a galactic community, then we have the exciting prospect of eventual contact and communication with other forms of consciousness that have emerged from the same cosmic processes that created us. Either possibility carries profound implications for how we understand our place in the universe and our responsibilities to future generations. The preservation and expansion of consciousness becomes not just a local concern but a cosmic imperative, essential for the universe's ongoing development of self-awareness and understanding. The whisper of the Milky Way speaks to us in the language of light and gravity, chemical elements and stellar cycles, reminding us that we are part of something infinitely larger than ourselves, while simultaneously being expressions of that larger reality. In learning to read the stories written in starlight, we discover our own cosmic ancestry and our potential cosmic destiny. The light that reaches us from distant stars carries information encoded over millions of years of travel through interstellar space. Spectroscopic analysis of this ancient light reveals the chemical compositions of stellar atmospheres, the velocities of galactic rotation, the temperatures and densities of interstellar gas clouds. Each photon that enters our telescopes represents a cosmic messenger that has traveled vast distances to deliver information about the structure and evolution of our galactic home. The gravitational waves recently detected by sensitive instruments on Earth provide another channel of cosmic communication, carrying information about the most violent events in galactic history, the collisions of black holes and neutron stars that create ripples in spacetime itself. These gravitational messages travel at the speed of light, but carry different information than electromagnetic radiation, revealing aspects of cosmic evolution that remain invisible to traditional telescopes. As the great spiral wheel of our galaxy turns in its ancient rhythm, carrying us all on a journey through space and time that began billions of years ago and will continue for billions of years to come, we find ourselves poised between the cosmic past and the cosmic future, temporary arrangements of galactic matter that have achieved the miraculous ability to contemplate the very processes that created us. This temporal perspective reveals the profound continuity that connects all phases of cosmic evolution, from the initial condensation of the first gas clouds to the emergence of self-aware beings capable of contemplating their own origins. We are both products of this cosmic evolution and agents of its future development, inheritors of billions of years of galactic history, and potential shapers of billions of years of galactic future. The Milky Way reminds us that we are both products and producers of cosmic evolution, both results and agents of the universe's ongoing development of complexity and consciousness. In understanding our galaxy, we understand ourselves. In appreciating its beauty, we develop our capacity for cosmic perspective. In contemplating its vastness, we discover both our humility and our significance as conscious participants in the greatest story ever told, the story of a universe that has learned to know itself through the emergence of minds capable of wonder, understanding, and love. This cosmic story continues to unfold around us and through us every moment, as new stars form in distant nebulae, as planets evolve and change, as consciousness develops and expands its understanding of cosmic processes. We are not separate from this story but integral parts of it, chapters in the galaxy's ongoing autobiography, participants in the universe's continuing journey toward greater complexity, beauty, and self-awareness. Rest now in this galactic perspective, in this connection to the vast spiral wheel of stars that is our cosmic home. Let the Milky Way's patient rotation inform your own sense of rhythm and belonging. Its stellar recycling inspire your understanding of transformation and renewal. Its spiral beauty remind you that the universe tends toward elegance and order even in its vastest structures. The whisper of the Milky Way will always be with you in every breath of air that contains atoms forged in stellar furnaces, in every ray of sunlight that carries energy generated in our star's nuclear core, in every moment of consciousness that represents the galaxy's ongoing development of self-awareness. You are the Milky Way experiencing itself, understanding itself, celebrating itself through your capacity for wonder and appreciation. As we prepare for the final stage of our cosmic journey, carry with you the gifts that our galaxy offers: the gift of perspective on cosmic scales, the gift of understanding deep time and vast distances, the gift of recognizing your place in the ongoing story of cosmic evolution. These gifts will serve you well as we turn our attention from the grand architecture of space to the intimate architecture of peace, as we prepare to return to the quiet center of awareness from which our journey began. Chapter 7. Closure and Final Contemplation. Our cosmic journey draws now toward its close, like a great symphony reaching its final movement, like a vast spiral galaxy completing one more turn in its ancient rotation. We have traveled together through realms of wonder that span from the intimate flash of meteors in our own atmosphere to the grand spiral architecture of our galactic home. We have witnessed the patient dance of asteroids, followed the elliptical pilgrimages of comets, walked the alien landscapes of Mars, and contemplated our place in the vast wheel of stars that cradles everything we have ever known. But now, as all journeys must, ours leads us home, not to a geographical location, but to that place of inner quiet from which all true exploration begins, and to which it must ultimately return. This is the center of awareness itself, the still point of consciousness around which all experiences, all discoveries, all moments of wonder naturally organize themselves. Let yourself settle now into this homecoming, feeling how each stage of our journey has prepared you for this moment of integration and rest. The meteors taught us about the beauty of brief encounters, the way that even the smallest visitors can illuminate vast stretches of darkness with their momentary brilliance. They reminded us that significance is not measured in duration, but in intensity, that sometimes the most profound gifts come from sources we least expect, burning bright in our awareness for just long enough to leave us forever changed. The comets showed us the power of patient pilgrimage, the way that some journeys require not speed but persistence, not urgency but faith in distant destinations. They demonstrated how transformation occurs when we allow ourselves to be warmed by the sources of light and energy in our lives, how we naturally develop our own tales of influence and beauty as we approach the things that matter most to us. In their willingness to give away parts of themselves in the service of spectacular display, comets taught us about the generosity required for true brilliance. The asteroids offered lessons in constancy and community, showing us how it is possible to maintain individual identity while participating in collective endeavors, how stability can coexist with motion, how the most important work sometimes consists simply of being present, maintaining position, and bearing witness to the passage of cosmic time. They reminded us that not all meaningful action is dramatic, that sometimes the greatest service we can provide is simply to remain faithful to our own orbital path while allowing others to follow theirs. Mars expanded our definition of home, challenging us to imagine life under alien skies, to contemplate the delicate conditions that make our Earth so special, while simultaneously recognizing the possibility that consciousness and community might flourish under very different circumstances. The red planet taught us about resilience in the face of change, about the way that worlds can transform dramatically while still maintaining their essential character, about the courage required to venture into unknown territories and make them familiar. And the Milky Way, our vast galactic home, provided the ultimate context for understanding our place in the cosmic story, revealing us to be not separate from the universe but expressions of it, temporary arrangements of stellar material that have achieved the remarkable capacity for self-reflection and wonder. Our galaxy taught us about cycles and deep time, about the way that matter and energy flow through cosmic systems, creating and destroying and recreating patterns of organization and beauty on scales that dwarf imagination. Each of these cosmic encounters has contributed something essential to our understanding, but more than that, each has served as a mirror in which we can recognize aspects of our own nature, our own journey, our own potential for transformation and growth. The universe we have explored is not external to us, it is the very substance of our being, the source of our consciousness, the context within which all our experiences unfold. This recognition brings with it a profound shift in perspective, a movement from seeing ourselves as isolated observers of cosmic phenomena to understanding ourselves as integral participants in cosmic evolution. You are not someone who looks at stars, you are stellar material that has organized itself into the capacity for stargazing. You are not someone who contemplates the universe, you are the universe contemplating itself through the temporary arrangement of cosmic elements that constitutes your consciousness. This shift from separation to integration, from observer to participant, naturally leads to a deep sense of peace and belonging. The vastness that might once have seemed overwhelming now feels like an embrace. The complexity that might once have seemed bewildering now appears as an expression of the same creative intelligence that manifests as your own capacity for understanding and appreciation. The distances that once seemed isolating now reveal themselves as the very spaciousness that allows for diversity, creativity, and the unfolding of countless unique stories within the larger narrative of cosmic evolution. Feel this peace settling into your awareness now, like stardust settling into the atmosphere, like cosmic radiation gently penetrating every cell of your being. This is not the peace of emptiness, but the peace of fullness, not the quiet of absence, but the quiet of presence so complete that it contains all possibilities without needing to manifest any of them. It is the peace of knowing your place in the cosmic order, of understanding that you belong here as surely as planets belong in their orbits or stars belong in their galaxies. In this peace, the concerns and anxieties that may have accompanied you on our journey begin to dissolve like morning mist touched by starlight. The problems that seemed so urgent, the fears that felt so overwhelming, the uncertainties that appeared so threatening, all of these reveal themselves to be temporary weather patterns in the vast sky of consciousness, no more permanent or substantial than clouds that form and dissipate in planetary atmospheres. This is not to diminish the reality of human challenges, or to suggest that difficulties don't matter. Rather, it is to provide a context large enough to hold both joy and sorrow, success and failure, clarity and confusion, recognizing all of these as natural phenomena in the ecosystem of consciousness, no more problematic than the existence of both day and night in planetary cycles, or both star formation and stellar death in galactic evolution. From the cosmic perspective we have cultivated together, you can see that every experience, every emotion, every thought that arises in awareness is part of the same universe that creates supernovas and spiral galaxies, meteor showers and comet tails. The same creative intelligence that organizes matter into increasingly complex structures, from atoms to molecules, to cells to organisms to ecosystems to planetary systems to galaxies, also organizes experience into the rich tapestry of human consciousness. This understanding naturally generates a profound sense of trust in the process of existence itself. Just as you don't need to consciously direct the motion of planets or the nuclear fusion in stellar cores, you don't need to micromanage every aspect of your own experience. There is a cosmic intelligence at work that is infinitely more subtle and sophisticated than any form of control the thinking mind might attempt to impose. Learning to relax into this intelligence, to allow it to organize your experience as naturally as it organizes the dance of galaxies, is one of the deepest forms of spiritual maturity. The universe we have explored together serves as a vast meditation hall, a cosmic temple in which the very act of existence becomes a form of worship, a celebration of the mystery that allows anything to exist at all rather than nothing. The silence between stars is not empty but pregnant with potential. The darkness of space is not absence but the fertile void from which all light emerges. The distances that separate cosmic objects are not barriers, but the very spaciousness that allows for relationship, for influence, for the gravitational poetry that binds all things together in one magnificent, ever-evolving whole. As you rest in this cosmic perspective, notice how naturally your breathing slows and deepens, how your heartbeat settles into a rhythm that echoes the pulsing of neutron stars, how your thoughts begin to move at the stately pace of galactic rotation, rather than the frantic speed of everyday anxiety. This is your natural state, not the artificial urgency of a culture obsessed with speed and efficiency, but the patient rhythm of cosmic time, the unhurried pace of deep processes that create lasting beauty and meaning. In this natural rhythm, you have all the time you need for whatever is truly important. The universe has been developing for nearly 14 billion years, and it shows no signs of being in a hurry. Stars form slowly, planets cool gradually, life evolves patiently, consciousness emerges in its own time. There is no cosmic deadline that requires you to accomplish everything immediately, no universal schedule that demands constant acceleration and achievement. Instead, there is the invitation to participate in the same patient creativity that shaped galaxies from gas clouds, that gradually enriched the cosmic medium with heavy elements, that slowly developed the conditions necessary for life and consciousness to emerge. This cosmic creativity works through rest as much as through action, through contemplation as much as through doing, through the willingness to let processes unfold in their own time rather than forcing them to conform to artificial timelines. The peace that emerges from this cosmic perspective is not dependent on external circumstances. It doesn't require that your life be free of challenges, or that you have resolved all your problems or achieved all your goals. Rather, it flows from the recognition that you are held by the same forces that maintain planets in their orbits, that you are guided by the same intelligence that organizes the spiral structure of galaxies, that you are loved by the same creative impulse that brings new stars to birth in cosmic nurseries throughout the universe. This love is not personal in the way human love is personal, but it is infinitely more reliable because it is woven into the very fabric of existence itself. It is the love that allows atoms to bond and molecules to form, that enables life to emerge from non-life, that permits consciousness to develop the capacity for wonder and appreciation. It is the love that ensures that nothing is ever truly lost, that every experience contributes something meaningful to the ongoing evolution of cosmic consciousness, that every moment of awareness adds something irreplaceable to the universe's understanding of itself. Resting in this cosmic love, you can let go of the need to justify your existence, to prove your worth, to earn your place in the universal story. You belong here as surely as any star belongs in its galaxy, not because of what you do or achieve, but because of what you are, a unique expression of the universe's capacity for self-awareness, a temporary but irreplaceable arrangement of cosmic intelligence exploring what it means to be conscious, creative, and capable of love. This belonging is not something you need to create or maintain through effort. It is given in the very fact of your existence, guaranteed by the same cosmic processes that created you, as natural and reliable as gravity or the nuclear forces that power stars. You can rest in this belonging as easily as the Earth rests in its orbit around the Sun, trusting that the intelligence that organized your emergence from stellar materials also knows how to guide your continuing evolution and eventual transformation. As our cosmic journey reaches its completion, take a moment to appreciate the profound privilege of consciousness itself, the remarkable fact that the universe has developed the capacity to experience wonder, to contemplate beauty, to recognize meaning and purpose in the vast web of relationships that connects all things. Through your awareness, the cosmos has awakened to its own magnificence. Through your appreciation, it learns to love its own creativity. Through your wonder, it discovers its own mystery. You are the universe's gift to itself, a way for cosmic intelligence to experience what it has created from the inside, to feel what it's like to be both part of the whole and aware of the whole simultaneously. This is why consciousness is so precious, why every moment of awareness is so valuable, why the capacity for wonder and appreciation represents one of the universe's greatest achievements. In the coming days and weeks, as you return to the familiar rhythms of daily life, remember that you carry this cosmic perspective with you always. The same atoms that make up your body have been on an incredible journey through space and time, participating in the life cycles of stars, the formation of planets, the emergence of life itself. You are walking stellar material, breathing cosmic gases, thinking with brain cells made from elements forged in nuclear furnaces billions of years ago. The peace you have touched in our cosmic journey is always available to you, not as an escape from daily life, but as the larger context that gives meaning and perspective to everyday experiences. When challenges arise, remember the patient persistence of comets on their long orbital journeys. When you feel small or insignificant, remember that you are made of the same materials as stars and galaxies. When you feel isolated or alone, remember that you are part of the vast web of cosmic relationships that connects everything to everything else across space and time. The universe we have explored together is not somewhere else, it is here, now, expressing itself as this moment, this breath, this heartbeat, this awareness that is reading these words. You don't need to travel to distant galaxies to experience cosmic wonder. You are cosmic wonder, embodied and aware, a temporary flowering of the same creative intelligence that guides the dance of planets and the birth of stars. Let this understanding settle into the deepest levels of your being, like cosmic rays penetrating to the Earth's core, like starlight warming the surface of distant worlds. You are held by the universe's love, guided by its intelligence, sustained by its creativity, and invited to participate in its ongoing evolution toward greater complexity, beauty, and consciousness. The cosmic journey never really ends, it simply changes form, moving from exploration to integration, from discovery to embodiment, from wonder at what is out there to recognition of what is in here, within the mysterious depths of awareness itself. You are both the traveler and the destination, both the seeker and the sought, both the question the universe is asking about itself, and the answer it is discovering through your existence. Rest now in this ultimate cosmic truth, in this recognition of your essential nature, as consciousness exploring itself through the adventure of embodied existence. Let the peace of the stars infuse your being. Let the patience of cosmic time inform your rhythm. Let the creativity of universal evolution inspire your own capacity for growth and transformation. The journey continues, but the traveling is done. The exploration persists, but the searching is complete. You are home in the cosmos, and the cosmos is home in you. All is well in the vast cathedral of space and time, and you are a cherished note in the eternal symphony of existence, playing your unique part in the cosmic song that has no beginning and no end, only endless variations on the theme of love exploring itself through the miracle of conscious awareness. Sleep now, if sleep is what calls you, in the embrace of cosmic peace. Dream, if dreams arise, of new worlds and distant stars. Wake, when waking comes, to the wonder of being alive in this incredible universe. And know always that you are exactly where you belong, exactly when you belong here, exactly who the universe needs you to be in this perfect, eternal, ever-changing moment of cosmic time. The stars will keep their vigil. The galaxies will continue their dance. And you will carry forward the gift of cosmic perspective, the blessing of wonder, the peace that comes from knowing your place in the grand design of existence itself. This is the completion of our journey, and this is the beginning of everything that follows a life lived in conscious communion with the cosmos, a heart that beats in rhythm with the universe, a mind that thinks with the intelligence that created galaxies and dreams with the creativity that brings new worlds to birth among the endless stars.